Beneath our feet, secrets slumber, whispers lost to time, buried deep beneath stone and earth. We think we are the first, the pinnacle, the only ones who ever reached for the stars. But sometimes the ground itself seems to breathe, a faint memory of something ancient, powerful, almost mythical, giant stones carved with purpose. Maps older than history, ruins that shouldn't exist. Scientists have uncovered impossible artifacts, hints of knowledge that should not have survived. Out-of-place relics, strange metals, forgotten cities, star charts etched long before telescopes. Each discovery shatters what we thought we knew, forcing us to ask, did another great civilization rise and fall long before us? Maybe the past isn't as empty as we think. Maybe, in the shadows of time, we are only the latest chapter in a story far older than our own. What else sleeps beneath the dust, waiting to be found? A great civilization is characterized by several key factors that demonstrate its advancement, influence, and lasting impact on human history. One crucial element is technological innovation, with great civilizations often pioneering new tools, techniques, and systems that revolutionize daily life and push the boundaries of human capability. Cultural achievements also play a significant role, encompassing art, literature, philosophy, and scientific understanding. These contributions not only enrich the lives of people within the civilization, but often continue to inspire and influence societies for generations to come. Another defining feature is the development of complex social and political structures. Great civilizations typically establish sophisticated systems of governance, law, and social organization that allow for the efficient management of large populations and territories. This often includes the creation of monumental architecture and infrastructure projects that stand as testaments to their engineering prowess and organizational abilities. Lastly, great civilizations tend to have a far-reaching impact beyond their immediate borders, whether through trade, cultural exchange, or territorial expansion. Their influence shapes the course of history, leaving an indelible mark on the world and often laying the groundwork for future advancements in human society. Archaeologists employ a range of scientific methods and critical analysis to distinguish between myth and historical fact. They rely on physical evidence, such as artifacts, structures, and human remains, to piece together the past. These tangible clues are examined using advanced techniques like radiocarbon dating, which provides accurate age estimates for organic materials. Archaeologists also use stratigraphy, the study of rock and soil layers, to establish chronological sequences and understand the context of discoveries. They compare findings across multiple sites and cultures to identify patterns and corroborate historical accounts. Written records, when available, are scrutinized and cross-referenced with archaeological evidence to verify their accuracy. Interdisciplinary collaboration plays a crucial role in this process. Archaeologists work with historians, linguists, geologists, and other experts to interpret evidence from various perspectives. They consider the cultural and social contexts of myths, recognizing that while legends may contain kernels of truth, they often incorporate symbolic or exaggerated elements. Ultimately, archaeologists maintain a skeptical approach, continuously questioning assumptions and revising theories as new evidence emerges. They acknowledge that our understanding of the past is always evolving, and they remain open to new interpretations that better explain the available data. Many people have inaccurate ideas about ancient civilizations, often shaped by popular media and outdated information. One widespread misconception is that the ancient Egyptians used slave labor to build the pyramids. In reality, archaeological evidence suggests that skilled workers and farmers constructed these monumental structures during the annual Nile flood season when they couldn't work in their fields. Another common misunderstanding involves the fall of the Roman Empire. While many believe it collapsed suddenly due to barbarian invasions, the process was actually gradual and complex, involving economic, political, and social factors over several centuries. The eastern half of the empire, known as the Byzantine Empire, continued to thrive for nearly 1,000 years after Rome's fall. There's also a persistent myth that people in the Middle Ages believed the Earth was flat. In fact, educated individuals in Europe during this time were well aware of Earth's spherical shape, a concept known since ancient Greek times. The idea that medieval people thought the world was flat is a 19th century fabrication. Lastly, many assume that ancient civilizations were primitive in their scientific and technological knowledge. However, numerous ancient cultures made remarkable advancements. The Mayans, for instance, developed a highly accurate calendar and made sophisticated astronomical observations, while the ancient Greeks created complex mechanical devices like the Antikythera mechanism, an early analog computer used to predict astronomical positions and eclipses. Our understanding of ancient civilizations has undergone a remarkable transformation over the past 100 years. Advances in archaeology, technology, and interdisciplinary research have revolutionized our knowledge of the past, revealing a far more complex and interconnected ancient world than previously imagined. One of the most significant changes has been the shift from focusing solely on monumental structures and elite artifacts to examining the lives of ordinary people. Archaeologists now use techniques like ground-penetrating radar and satellite imagery to uncover entire cities and trade networks, providing a broader view of ancient societies. This approach has revealed sophisticated urban planning, advanced agricultural systems, and complex social structures in civilizations once considered primitive. Genetic studies and isotope analysis have also transformed our understanding of ancient populations. These techniques allow researchers to trace migration patterns, understand diet and health, and even identify familial relationships among ancient individuals. Such findings have challenged long-held assumptions about the isolation of ancient cultures, revealing instead a world of frequent cultural exchanges and long-distance trade. Moreover, the decipherment of ancient scripts and the analysis of texts have provided invaluable insights into the thoughts, beliefs, and daily lives of ancient peoples. From the translation of Linear B to the ongoing work on Mayan hieroglyphs, these breakthroughs have given voice to long silent civilizations, allowing us to appreciate their unique perspectives and contributions to human history. Technology has revolutionized the field of archaeology, providing researchers with powerful tools to uncover and analyze evidence of lost civilizations. Advanced imaging techniques like ground-penetrating radar and LiDAR allow archaeologists to peer beneath the Earth's surface without disturbing the site. These methods can reveal hidden structures, burial chambers, and entire city layouts that were previously invisible to the naked eye. Satellite imagery has also transformed the search for ancient settlements. By analyzing subtle changes in vegetation and terrain from space, researchers can identify potential sites of interest across vast areas. This approach has led to the discovery of numerous lost cities in dense jungles and remote deserts, dramatically expanding our understanding of ancient cultures. In the laboratory, cutting-edge dating methods such as accelerator mass spectrometry enable scientists to determine the age of artifacts with unprecedented accuracy. Genetic analysis of ancient DNA extracted from bones and teeth provides insights into the movements and relationships of ancient populations. Meanwhile, three-dimensional scanning and printing technology allows for the creation of detailed replicas of fragile artifacts, facilitating study and preservation. Computer modeling and virtual reality are increasingly used to reconstruct ancient environments and simulate how people might have lived in the past. These digital tools help researchers test theories about everything from building techniques to social organization, bringing lost civilizations to life in ways that were unimaginable just a few decades ago. As technology continues to advance, our ability to uncover and understand the secrets of ancient cultures grows ever more sophisticated. Researchers employ a variety of techniques to determine the age of ancient artifacts and structures. One of the most well-known methods is radiocarbon dating, which measures the decay of carbon-14 isotopes in organic materials. This technique is effective for items up to about 50,000 years old. For older artifacts and geological formations, scientists turn to other radiometric dating methods. These include potassium-argon dating and uranium-lead dating, which can measure ages in the millions or even billions of years. These techniques rely on the predictable decay of radioactive isotopes in rocks and minerals. Dendrochronology, or tree ring dating, is another valuable tool for archaeologists. By analyzing the pattern of growth rings in wooden artifacts or structures, researchers can pinpoint the year a tree was cut down, providing accurate dates for wooden objects. Thermoluminescence dating is used for ceramics and other materials that have been heated in the past. This method measures the accumulated radiation dose of the material since it was last heated, giving an estimate of its age. These diverse dating techniques, often used in combination, allow scientists to piece together a comprehensive timeline of human history and Earth's geological past. Studying civilizations without written records presents archaeologists and historians with significant hurdles. One major challenge is piecing together a comprehensive understanding of their daily lives, beliefs, and social structures. Without texts to provide direct insights, researchers must rely heavily on material remains and artifacts, which can be fragmentary or open to multiple interpretations. Another difficulty lies in determining accurate timelines and chronologies. Written records often provide specific dates and sequences of events, but their absence forces scientists to depend on methods like radiocarbon dating and stratigraphy. These techniques, while valuable, sometimes offer less precise timeframes, making it challenging to establish clear historical narratives. Language and communication pose additional obstacles. Without written examples, deciphering spoken languages becomes nearly impossible, leaving gaps in our understanding of how these societies interacted, traded, or spread their ideas. This linguistic barrier also complicates efforts to interpret symbols, art, and other cultural expressions that might hold key information about their worldviews and traditions. Furthermore, tracing the development and spread of technologies, agricultural practices, and social innovations becomes more complex without written accounts. Researchers must instead rely on archaeological evidence and comparative studies with other cultures, which can lead to uncertainties and debates within the scientific community. Despite these challenges, ongoing advancements in scientific techniques continue to shed new light on these ancient societies, gradually unveiling their hidden histories. Defining advanced in the context of ancient societies involves considering multiple factors beyond just technological achievements. We look at the complexity of their social structures, governance systems, and cultural expressions. The development of writing systems, for instance, is often seen as a key indicator of an advanced society, as it allows for the preservation and transmission of knowledge across generations. Urban planning and architecture also play crucial roles in our assessment. Societies that constructed large-scale monuments, intricate irrigation systems, or sprawling cities with organized layouts are typically considered more advanced. The ancient Egyptians, with their pyramids and complex burial practices, exemplify this aspect of advancement. Economic systems and trade networks are another important measure. Societies that engaged in long-distance trade, developed sophisticated economic practices, or created standardized currency systems demonstrate a high level of advancement. The extensive trade routes of the ancient Phoenicians or the complex market systems of the Aztecs are prime examples of economic sophistication. Scientific and mathematical knowledge also factor into our definition of advanced societies. Cultures that made significant astronomical observations, developed accurate calendars, or contributed to fields like mathematics and medicine are often regarded as highly advanced for their time. The ancient Greeks' contributions to geometry and the Mayas' precise astronomical calculations showcase this type of advancement in ancient societies. Archaeologists and historians often uncover surprising evidence that challenges our understanding of ancient civilizations. One key indicator of advanced technology is the presence of sophisticated metallurgy. The discovery of complex alloys or precisely crafted metal objects suggests a deep understanding of material science. For instance, the recent analysis of ancient Roman concrete has revealed its superior durability compared to modern versions, hinting at lost knowledge in construction techniques. Another sign of advanced civilization is the existence of precise astronomical calculations and structures aligned with celestial events. The ancient Mayan calendar, with its accurate predictions of solar eclipses, demonstrates a level of mathematical and astronomical expertise that was once thought impossible for its time. Similarly, the precise orientation of Egyptian pyramids to cardinal points suggests advanced surveying and engineering skills. Evidence of long-distance trade networks can also indicate a more sophisticated society. The presence of goods from far-flung regions implies not only advanced transportation methods, but also complex economic systems and diplomatic relations. The discovery of Chinese silk in ancient Roman tombs, for example, reveals the existence of extensive trade routes spanning thousands of miles. Lastly, the presence of advanced medical knowledge can be a strong indicator of a highly developed civilization. Archaeological findings of sophisticated surgical tools, evidence of complex medical procedures like trepanation, or written texts describing advanced healing practices all suggest a level of medical understanding that might surpass initial assumptions about a particular culture's capabilities. Natural disasters have played a significant role in the decline and disappearance of many ancient civilizations throughout history. These catastrophic events, often struck with little warning, overwhelming societies and leaving lasting impacts that contributed to their eventual downfall. Earthquakes, for instance, could devastate entire cities in seconds, destroying vital infrastructure and causing massive loss of life. The ancient Roman city of Pompeii stands as a stark reminder of the destructive power of volcanic eruptions, with Mount Vesuvius burying the thriving community under ash and pumice in 79 CE. This cataclysmic event effectively erased Pompeii from existence for centuries. Prolonged droughts and changes in climate patterns have also been linked to the collapse of several ancient civilizations. The Mayan civilization of Central America, for example, experienced a series of severe droughts between 750 and 950 CE. These extended dry periods likely led to crop failures, famine, and social unrest, contributing to the abandonment of many Mayan cities and the eventual decline of their once great civilization. Floods and tsunamis have likewise left their mark on ancient societies. Some researchers suggest that a massive tsunami might have played a role in the downfall of the Minoan civilization on the island of Crete around 1600 BCE. Such catastrophic events could wipe out coastal settlements, disrupt trade networks, and lead to widespread food shortages, all of which could destabilize even the most advanced ancient societies. Archaeological discoveries in recent years have continued to challenge our understanding of human history and ancient civilizations. One intriguing find is the massive geoglyphs discovered in the Amazon rainforest. These enormous geometric patterns, only visible from the air, suggest complex societies existed in the region long before European contact, reshaping our view of pre-Columbian Amazonian cultures. Another puzzling discovery is the Göbekli Tepe site in Turkey. This ancient temple complex, dating back 12,000 years, predates agriculture and settled communities. Its sophisticated construction and intricate carvings have forced archaeologists to reconsider the capabilities of hunter-gatherer societies and the origins of organized religion. In Egypt, the void discovered within the Great Pyramid of Giza using cosmic ray imaging has sparked intense debate. This large, previously unknown chamber has left Egyptologists speculating about its purpose and contents, potentially rewriting our understanding of ancient Egyptian construction techniques and burial practices. Lastly, the discovery of Homo naledi fossils in South Africa has raised questions about human evolution. These small-brained hominins, which lived as recently as 230,000 years ago, show a mix of primitive and modern features. Their presence alongside early modern humans challenges linear models of human evolution and suggests a more complex evolutionary history than previously thought. Unexplained artifacts have long puzzled archaeologists and historians, forcing us to question our established timelines of human development. These enigmatic objects, often found in locations or geological layers where they seemingly do not belong, challenge our conventional understanding of ancient civilizations and technological progress. One such example is the Antikythera mechanism, an ancient Greek device discovered in a shipwreck. This complex astronomical calculator, dating back to around 150 BC, demonstrates a level of technological sophistication previously thought impossible for that era. Its intricate gears and ability to predict celestial events suggest that ancient peoples possessed far more advanced knowledge than we once believed. Similarly, the discovery of the Baghdad battery, a clay pot containing an iron rod and copper cylinder, has led some researchers to speculate about the possibility of ancient electrical technology. While its true purpose remains debated, its mere existence raises questions about the extent of early scientific understanding. These artifacts, and others like them, challenge us to reconsider our assumptions about the past. They hint at the possibility of lost knowledge, advanced ancient civilizations, or even alternative paths of technological development that differ from our current historical narrative. As we continue to unearth more unexplained artifacts, we may need to revise our understanding of human history, acknowledging that our ancestors may have been more ingenious and capable than we previously imagined. Out-of-place artifacts, often called OOPArts, are objects found in geological or archaeological contexts that seem to defy conventional understanding of human history and technological capabilities. These puzzling discoveries challenge our established timelines and force us to reconsider what we know about ancient civilizations and their technological advancements. One famous example is the Antikythera mechanism, an ancient Greek device discovered in a shipwreck. This complex geared mechanism, dating back to around 100 BCE, was capable of predicting astronomical positions and eclipses with remarkable accuracy. Its sophistication has led some researchers to compare it to a modern analog computer, raising questions about the extent of ancient Greek technological knowledge. Another intriguing OOPArt is the Baghdad battery, a set of terracotta pots containing copper cylinders and iron rods discovered in Iraq. Dating to around 250 BCE, some scientists suggest these artifacts might have been used as primitive batteries, potentially indicating early understanding of electricity in ancient Mesopotamia. While many OOPArts have conventional explanations, others remain mysterious, fueling debates among archaeologists, historians, and enthusiasts. These artifacts remind us that our understanding of the past is continually evolving, and that ancient civilizations may have possessed knowledge and capabilities beyond what we currently attribute to them. Archaeologists employ a range of sophisticated techniques to verify the authenticity of unusual findings. One key method is stratigraphy, which examines the layers of Earth in which an artifact is found. By analyzing these layers, experts can determine the relative age of an object and whether it matches the expected time period. Carbon dating and other radiometric techniques provide more precise age estimates for organic materials. These methods measure the decay of radioactive isotopes, offering a reliable way to date artifacts up to 50,000 years old. For inorganic materials, thermoluminescence dating can be used, which measures the accumulated radiation dose since an item was last heated. Chemical analysis plays a crucial role in authentication. Spectrometry and X-ray fluorescence can reveal the elemental composition of artifacts, helping experts determine if the materials are consistent with the purported time and place of origin. Microscopic examination is also vital, as it can reveal telltale signs of modern manufacturing processes or deliberate aging techniques used by forgers. Experts also consider the broader archaeological context. They examine how an artifact relates to other finds from the same site and period, and whether it fits with known historical and cultural patterns. This holistic approach helps archaeologists spot anomalies that might indicate a fake or misplaced item, ensuring that only genuine artifacts contribute to our understanding of the past. Ancient civilizations developed remarkable technologies that continue to astonish us today. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, is a sophisticated astronomical calculator dating back to the 2nd century BCE. This complex device used intricate gears to predict celestial events and track the movements of heavenly bodies with astonishing accuracy. In ancient Rome, engineers created an extensive network of aqueducts and underground sewers that rivaled modern water management systems. These structures, built without advanced surveying tools or powerful pumps, transported water over vast distances and helped maintain public health in bustling cities. The ancient Egyptians demonstrated incredible engineering prowess with their construction techniques. They built massive structures like the Great Pyramid of Giza using methods that still puzzle experts today. The precision of their stone cutting and the ability to transport and stack enormous blocks of stone speak to a level of technological sophistication that seems almost impossible for their time. Chinese inventors were also far ahead of their contemporaries. They developed the compass, gunpowder, and paper-making techniques long before these technologies spread to other parts of the world. The precision of ancient Chinese seismographs, capable of detecting earthquakes from great distances, showcases their advanced understanding of natural phenomena and mechanical engineering. Anachronistic artifacts, objects that seem out of place in time, have long puzzled archaeologists and historians. These perplexing finds challenge our understanding of technological progress and cultural development. While some alleged anachronisms have been debunked, others remain mysterious and continue to spark debate among experts. One explanation for seemingly anachronistic artifacts is misinterpretation. Objects can sometimes appear more advanced or different from their actual time period due to our limited understanding of ancient technologies or cultural practices. What might seem impossible for a particular era could simply be the result of ingenious craftsmanship or techniques lost to time. Another factor to consider is the possibility of contamination or intrusion in archaeological sites. Objects from different time periods can become mixed due to natural processes like erosion or human activities such as construction and agriculture. This mixing can lead to the appearance of anachronisms when items from a later period end up in layers associated with earlier times. In some cases, anachronistic artifacts might be the result of trade or cultural exchange between distant civilizations. Advanced objects could have traveled far from their place of origin, appearing out of context in regions where such technology was not yet developed. Careful analysis of materials and manufacturing techniques can often reveal the true origins of these puzzling finds, helping to resolve apparent anachronisms and shedding light on ancient trade networks and cultural interactions. Interdisciplinary research is crucial in unraveling the enigmas of the cosmos. When scientists from different fields combine their expertise, they often unlock new perspectives and solutions that might have remained hidden within the confines of a single discipline. Astronomers, for instance, frequently collaborate with physicists to interpret the behavior of celestial objects. This partnership has led to groundbreaking discoveries about dark matter and dark energy, concepts that challenge our understanding of the universe's composition. Similarly, astrobiologists work alongside chemists and geologists to study the potential for life on other planets, analyzing the chemical signatures of distant worlds and comparing them to the conditions that fostered life on Earth. Computer scientists and mathematicians also play a vital role in modern space exploration. They develop sophisticated algorithms and data analysis techniques that help process the vast amounts of information collected by telescopes and space probes. This computational power has enabled researchers to detect faint signals from the early universe and identify patterns in cosmic phenomena that were previously invisible to human observers. The fusion of biology and astronomy has given rise to the field of astrobiology, which seeks to understand how life might arise and evolve in diverse cosmic environments. This interdisciplinary approach has expanded our search for extraterrestrial life beyond the traditional habitable zone concept, considering extreme environments on Earth as analogues for potential life-sustaining conditions elsewhere in the universe. Controversial artifacts often challenge established archaeological theories, forcing researchers to re-evaluate their understanding of ancient cultures and human history. These objects, which defy conventional explanations or appear out of place in the archaeological record, can spark intense debates within the scientific community and sometimes even capture public imagination. When credible, controversial artifacts emerge, they can lead to significant shifts in archaeological thinking. For instance, the discovery of sophisticated stone tools in North America dating back over 100,000 years has challenged long-held beliefs about when humans first arrived in the Americas. This finding has prompted archaeologists to reconsider migration patterns and timelines, potentially rewriting chapters of human prehistory. However, controversial artifacts also present challenges. Verifying their authenticity and context is crucial, as forgeries or misinterpreted objects can mislead researchers and the public alike. Additionally, some controversial finds may be seized upon by fringe theorists to support pseudoscientific claims, further complicating the scientific discourse. Ultimately, controversial artifacts serve as catalysts for scientific progress. They encourage archaeologists to question assumptions, refine dating techniques, and seek new evidence. This process of scrutiny and debate helps strengthen the field of archaeology, ensuring that our understanding of the past continues to evolve based on the best available evidence. Throughout history, humans have created remarkable structures that continue to baffle modern engineers and archaeologists. The Great Pyramid of Giza in Egypt stands as a testament to ancient ingenuity. Built around 4,500 years ago, its precise construction and alignment with cardinal directions remain a subject of debate. The massive limestone blocks, some weighing up to 80 tons, were transported and stacked with astonishing accuracy, leaving experts to speculate about the advanced tools and techniques used by ancient Egyptians. Halfway across the world, the ancient city of Machu Picchu in Peru presents another architectural marvel. Perched high in the Andes Mountains, its stone structures fit together so perfectly that not even a knife blade can be inserted between them. This precision stonework, known as ashlar masonry, was achieved without mortar and has withstood centuries of earthquakes and erosion. In modern-day Lebanon, the Temple of Jupiter at Baalbek features colossal stone blocks in its foundation, with some weighing up to 1,000 tons. These megaliths, larger than any used in the Egyptian pyramids, were somehow quarried, transported, and lifted into place with incredible precision. The methods used to move these massive stones remain a mystery, challenging our understanding of ancient engineering capabilities. Another enigmatic structure is Sacsayhuaman in Cusco, Peru. This fortress complex consists of massive walls made of irregularly shaped stones that interlock perfectly. Some of these stones weigh up to 120 tons, yet they were cut and fitted with such precision that no mortar was needed. The complexity of this construction has led to various theories about the tools and techniques used by the ancient Inca, including speculation about advanced technology or extraterrestrial assistance. Researchers employ a range of rigorous methods to differentiate between hoaxes and genuine mysterious artifacts. The process begins with thorough documentation and careful examination of the object itself. Scientists use advanced imaging techniques such as X-rays, computed tomography scans, and multispectral imaging to analyze the internal structure and composition of artifacts without causing damage. Material analysis plays a crucial role in authentication. Experts conduct tests to determine the age of materials, often using radiocarbon dating for organic substances or thermoluminescence for ceramics. They also examine the chemical composition and microscopic features of the artifact, looking for signs of modern manufacturing processes or materials that would indicate a hoax. Context is equally important in the investigation. Archaeologists study the site where the artifact was discovered, considering factors like soil composition, surrounding objects, and historical records. They look for consistency between the artifact and its purported time period and culture. Provenance research, tracing the history of ownership and discovery, can reveal red flags or support authenticity. Collaboration across disciplines is often necessary to fully evaluate mysterious artifacts. Historians, linguists, geologists, and other specialists may be called upon to provide insights from their respective fields. This multidisciplinary approach helps ensure a comprehensive evaluation, reducing the likelihood of being deceived by sophisticated hoaxes while validating truly enigmatic discoveries. Ancient civilizations have left behind remarkable structures and artifacts that continue to astound modern engineers and archaeologists. The Great Pyramid of Giza stands as a testament to the precision and skill of ancient Egyptian builders. Its near-perfect alignment with true north and the exact fit of its massive stone blocks demonstrate a sophisticated understanding of geometry and construction techniques. In South America, the Incan city of Machu Picchu showcases advanced water management systems and earthquake-resistant architecture. The interlocking stone walls, built without mortar, have withstood centuries of seismic activity. This suggests a deep knowledge of geology and structural engineering that rivals modern practices. The Roman aqueducts and road networks reveal a mastery of civil engineering that was far ahead of its time. The durability of Roman concrete, which has lasted for 2 millennia in some cases, still puzzles scientists today. Some Roman structures have even proven more resilient than their modern counterparts. Ancient Indian and Chinese texts describe advanced metallurgical processes, including the creation of high-quality steel and complex alloys. The famous Iron Pillar of Delhi, which has resisted corrosion for over 1,500 years, stands as evidence of this metallurgical expertise. These examples challenge our assumptions about the technological capabilities of ancient societies and suggest that their engineering knowledge was far more advanced than previously thought. The Great Pyramid of Giza stands as a monumental testament to the ingenuity and skill of ancient Egyptian builders. This colossal structure challenges our understanding of ancient capabilities in several ways. Firstly, the sheer precision of its construction is astounding. The base of the pyramid is almost perfectly level, with only a few centimeters of variation across its entire 430-meter perimeter. This level of accuracy was achieved over 4,500 years ago, long before the advent of modern surveying tools. The pyramid's alignment is equally impressive. Its sides are oriented almost exactly with the 4 cardinal directions, deviating by less than 1/10 of a degree. This suggests a sophisticated understanding of astronomy and the ability to make precise measurements over large distances. Perhaps most puzzling is the transportation and placement of the pyramid's massive stone blocks. Some of these blocks weigh up to 80 tons and were quarried from sites as far as 800 kilometers away. The methods used to move these enormous stones and stack them with such precision remain a subject of debate among archaeologists and engineers. These feats challenge our assumptions about the technological capabilities of ancient civilizations and prompt us to reconsider the ingenuity of our ancestors. Ancient civilizations demonstrated remarkable skill in stone cutting, leaving us with awe-inspiring monuments that continue to baffle modern engineers. The Great Pyramid of Giza in Egypt stands as a testament to this precision. Its base is leveled to within just a fraction of an inch across its entire 456-foot width, an astounding feat considering the primitive tools available at the time. In South America, the Inca site of Ollantaytambo showcases massive stone blocks fitted together so tightly that not even a knife blade can be inserted between them. These stones, some weighing over 50 tons, were cut and shaped with such accuracy that they have withstood centuries of earthquakes. Halfway across the world, the temples of Angkor Wat in Cambodia display intricate stone carvings and perfectly aligned blocks. The builders achieved such precision that the entire structure appears to have been cast from a single piece of stone rather than assembled from individual blocks. At Pumapunku in Bolivia, we find perhaps the most perplexing example of ancient stone cutting. Here, enormous andesite blocks were cut with right angles, straight edges, and even small drill holes, all executed with a level of precision that would challenge modern stonemasons equipped with power tools. Ancient civilizations developed ingenious methods to transport and manipulate massive stone blocks, showcasing their remarkable engineering skills. The Egyptians, for instance, likely used a combination of sleds, ramps, and levers to move the enormous limestone blocks used in pyramid construction. They would wet the sand in front of the sleds to reduce friction, making it easier to pull the heavy loads across the desert. In South America, the Inca employed a technique called ashlar masonry, fitting massive stones so precisely that mortar was unnecessary. They likely used a system of ramps, rollers, and pulleys to transport stones weighing up to several hundred tons. The Inca also took advantage of the natural terrain, quarrying stones from higher elevations and using gravity to assist in their transport downhill. The ancient Greeks and Romans utilized sophisticated cranes and pulley systems to lift and position large stone blocks. They also developed the Lewis iron, a device inserted into a carefully cut hole in a stone block, allowing it to be lifted securely. This innovation greatly enhanced their ability to construct tall structures and intricate architectural designs. Across cultures, these ancient builders also employed techniques such as stone splitting using wooden wedges soaked in water, which would expand and crack the stone along natural faults. This method allowed them to create more manageable pieces from larger stone masses. The ingenuity and persistence of these ancient civilizations continue to astound modern engineers and archaeologists, reminding us of the remarkable achievements possible with determination and creative problem-solving. The acoustic properties of ancient structures offer fascinating insights into the knowledge and intentions of their builders. Many prehistoric and early historic sites, from Stonehenge to the Mayan pyramids, demonstrate remarkable sound qualities that were likely not accidental. For instance, some Neolithic chamber tombs in Europe produce resonant frequencies that match those of human brainwaves associated with altered states of consciousness. This suggests that the builders may have understood how certain sounds could induce trance-like states, possibly for ritual or spiritual purposes. In ancient Greek and Roman theaters, the precise arrangement of stone seating created natural amplification, allowing even whispered words on stage to be heard clearly at the back of the audience. This acoustic mastery reveals a sophisticated understanding of sound propagation and architectural design. Similarly, the Great Ball Court at Chichen Itza in Mexico exhibits an extraordinary acoustic phenomenon where a whisper at one end can be heard clearly at the other, nearly 150 meters away. Such acoustic marvels indicate that ancient civilizations possessed advanced knowledge of sound behavior and intentionally incorporated these principles into their constructions, likely for ceremonial, communicative, or possibly astronomical purposes. Ancient water management systems were remarkable feats of engineering that laid the groundwork for our modern approaches. The Romans, for example, constructed extensive aqueduct networks that transported water over vast distances using gravity alone. These systems utilized precisely calculated gradients to maintain water flow, a principle still applied in modern pipeline design. In ancient Persia, engineers developed qanats, underground channels that tapped into aquifers and brought water to the surface for irrigation and drinking. This ingenious system minimized water loss through evaporation, a concern that remains relevant in contemporary water conservation efforts. Similarly, the Mayans built sophisticated rainwater collection systems and reservoirs to sustain their cities through dry seasons, demonstrating an early understanding of water cycle management. Modern engineering has built upon these foundational concepts, incorporating advanced materials, pumping technologies, and computerized control systems. Today, we use sophisticated water treatment plants, desalination facilities, and smart distribution networks that can detect leaks and adjust flow rates automatically. However, the core principles of water conveyance, storage, and conservation remain remarkably similar to those employed by our ancestors. While ancient systems relied primarily on gravity and manual operation, modern systems harness electrical power and automation to achieve greater efficiency and reach. Nevertheless, engineers today still marvel at the ingenuity of ancient water management solutions, often drawing inspiration from these time-tested designs when developing sustainable water systems for the future. Ancient civilizations demonstrated remarkable metallurgical skills, often surpassing expectations for their time. Archaeological evidence reveals sophisticated metal working techniques dating back thousands of years. In ancient Egypt, craftsmen produced intricate gold jewelry and ornaments as early as 3,000 years before the Common Era. These artifacts showcase advanced techniques like granulation and filigree, requiring precise temperature control and expert handling of metals. The Hittites of Anatolia were pioneers in ironworking, developing some of the earliest known steel production methods around 1400 BCE. Their ability to create stronger, more durable weapons gave them a significant military advantage. In South America, the Incas and their predecessors mastered complex alloys, creating a gold-copper blend called tumbaga. This alloy allowed them to create objects with a lower melting point, enabling more intricate designs. Ancient Chinese metallurgists were particularly advanced, producing high-quality cast iron as early as the 5th century BCE. They developed blast furnaces capable of reaching temperatures over 1,300 degrees Celsius, allowing for large-scale iron production. This technological edge contributed to China's early industrial capabilities and military power. In India, the creation of the famous Damascus steel, known for its distinctive watery pattern and exceptional strength, showcases another pinnacle of ancient metallurgy. The exact technique for creating this steel was lost for centuries, highlighting the advanced nature of this metallurgical process. These examples from across the ancient world demonstrate that our ancestors possessed sophisticated understanding and control of metalworking, often achieving results that still impress us today. Ancient civilizations across the globe left behind remarkable structures that showcase their deep understanding of celestial movements. These astronomical alignments reveal a level of knowledge that often surprises modern observers. The Great Pyramid of Giza in Egypt stands as a testament to ancient Egyptian astronomy. Its sides are aligned with astonishing precision to the cardinal directions, deviating by less than 1/10 of a degree. This alignment allowed the pyramid to cast no shadow at noon during the spring equinox, a feat requiring careful observation and calculation. Halfway across the world, the Mayan city of Chichen Itza features the Pyramid of Kukulkan, designed to create a mesmerizing light and shadow display during the equinoxes. As the sun sets, triangular shadows form along the pyramid's stairs, creating the illusion of a serpent descending the structure. This effect demonstrates not only astronomical knowledge, but also a sophisticated understanding of architecture and light manipulation. In England, Stonehenge stands as one of the most famous examples of ancient astronomical alignments. The monument's layout corresponds to the movements of the sun, moon, and stars. Its main axis aligns with the midsummer sunrise and midwinter sunset, while other stone arrangements track lunar cycles and other celestial events. These alignments required years of careful observation and an intricate understanding of celestial mechanics, challenging our perceptions of ancient scientific capabilities. Ancient Roman concrete stands as a testament to the ingenuity of our ancestors, often outlasting modern counterparts by centuries. The Pantheon in Rome, constructed nearly 2,000 years ago, boasts a massive, unreinforced concrete dome that remains the largest of its kind. This remarkable structure has withstood earthquakes, wars, and the relentless march of time, showcasing durability that many modern buildings struggle to match. Another prime example is the ancient Roman harbor structures found along the Mediterranean coast. These underwater concrete structures have endured constant exposure to seawater for 2 millennia, yet they continue to gain strength over time. This is due to a remarkable chemical reaction between the seawater and the volcanic ash used in the concrete mix, which forms new minerals that reinforce the concrete structure. In contrast, modern concrete often begins to deteriorate after just 50 years, especially in marine environments. The ancient Romans' use of volcanic ash, specifically from the area around Mount Vesuvius, created a more flexible and crack-resistant material than today's Portland cement-based concretes. This flexibility allowed Roman structures to better withstand ground movements and environmental stresses. The longevity of these ancient concretes has sparked renewed interest among modern researchers. Scientists are now studying the composition and techniques used by the Romans, aiming to develop more durable and environmentally friendly concrete for future construction projects. These ancient examples remind us that sometimes the most advanced solutions can be found by looking to the past. Mining has undergone a remarkable transformation over the centuries. Ancient civilizations relied heavily on manual labor, using simple tools like picks, hammers, and chisels to extract valuable minerals from the earth. These early miners often worked in dangerous conditions, digging shallow pits or tunneling into hillsides with limited understanding of structural integrity or ventilation. In contrast, modern mining operations employ sophisticated machinery and advanced technology. Massive excavators and trucks now move tons of earth in a single day, accomplishing what would have taken ancient miners months or even years. Contemporary techniques also include open-pit mining for near-surface deposits and deep underground operations that can reach depths of several kilometers. One of the most significant advancements in mining is the use of explosives and controlled blasting, which allows for efficient rock fragmentation. This is complemented by cutting-edge drilling equipment that can bore precise holes for both exploration and extraction. Additionally, modern miners benefit from detailed geological surveys, three-dimensional modeling, and remote sensing technologies that help pinpoint mineral deposits with unprecedented accuracy. Environmental considerations and safety standards have also become integral to contemporary mining practices. While ancient miners had little regard for ecological impact, today's operations often implement extensive reclamation plans and pollution control measures. Moreover, modern miners use advanced personal protective equipment and follow strict safety protocols, drastically reducing the risks that were once commonplace in this inherently dangerous profession. Archaeological findings reveal intriguing connections between ancient civilizations separated by great distances. Trade artifacts discovered far from their places of origin indicate extensive networks spanning continents. For instance, Roman coins have been unearthed in India, while Chinese silk has been found in ancient Egyptian tombs. Similarities in architectural styles and construction techniques also suggest knowledge transfer across cultures. The step pyramids of ancient Egypt bear a striking resemblance to those found in Mesoamerica, despite the vast oceans separating these civilizations. This has led some researchers to propose the possibility of transoceanic contact long before the age of exploration. Genetic studies provide further evidence of ancient intercontinental connections. DNA analysis of indigenous populations in the Americas has revealed genetic markers typically associated with Polynesian ancestry, hinting at prehistoric Pacific voyages. Similarly, linguistic analysis has uncovered surprising similarities between languages spoken in geographically distant regions, suggesting possible cultural exchanges. While these findings do not conclusively prove direct contact between all ancient civilizations, they challenge our understanding of prehistoric human migration and interaction. The evidence points to a more interconnected ancient world than previously thought, with ideas, technologies, and people traveling across vast distances through complex networks of trade and exploration. The striking similarities found in myths and legends across different cultures often point to shared origins or historical interactions between societies. These common threads in storytelling suggest that ancient peoples may have had more contact and exchange than previously thought. One compelling example is the prevalence of flood myths in numerous cultures worldwide. From the biblical story of Noah's Ark to the Mesopotamian epic of Gilgamesh and the Mayan Popol Vuh, tales of a great deluge that nearly wipes out humanity appear with remarkable consistency. This widespread motif could indicate a shared ancestral story, perhaps based on actual events from early human history. Creation myths also show intriguing parallels across diverse cultures. Many feature the concept of the world emerging from chaos or darkness, often involving cosmic eggs or primordial beings. These similarities might reflect common human attempts to explain the origins of the universe, or they could hint at ancient cultural diffusion. Hero myths provide another fascinating area of comparison. Stories of individuals embarking on quests, battling monsters, and achieving great feats appear in folklore from Europe to Asia to the Americas. The recurring elements in these tales suggest universal human experiences and aspirations, while also raising questions about possible cultural exchanges in prehistoric times. These shared mythological patterns continue to intrigue researchers, offering tantalizing clues about our collective human past and the interconnectedness of ancient civilizations. Genetic studies have revolutionized our understanding of ancient human migrations, offering unprecedented insights into our ancestors' journeys across the globe. By analyzing DNA from both modern populations and ancient remains, scientists have pieced together a complex tapestry of human movement spanning tens of thousands of years. One of the most significant revelations is the confirmation of the out of Africa theory. Genetic evidence shows that all non-African populations today descend from a small group of Homo sapiens who left Africa around 60,000 to 70,000 years ago. This group, possibly numbering only a few thousand individuals, carried with them a subset of African genetic diversity that would eventually spread across the entire planet. These studies have also uncovered surprising interactions between different human species. For instance, genetic analysis reveals that modern non-African humans carry small amounts of Neanderthal DNA, indicating interbreeding between our species and Neanderthals after leaving Africa. Similarly, some Asian populations show traces of Denisovan DNA, another extinct human species. Genetic research has also shed light on more recent migrations, such as the peopling of the Americas. DNA evidence suggests that the ancestors of Native Americans crossed a land bridge connecting Siberia to Alaska around 15,000 years ago, spreading rapidly across North and South America. These genetic studies continue to refine our understanding of human history, often challenging long-held assumptions and revealing the intricate story of our species' global journey. Linguistic similarities across continents provide intriguing evidence for prehistoric connections between distant human populations. These shared language features suggest ancient migrations and cultural exchanges that occurred long before recorded history. One striking example is the similarities found between some Native American languages and certain Eurasian language families. Linguists have identified common roots and grammatical structures that point to possible prehistoric migrations across the Bering Strait land bridge. These connections support theories of early human movement from Asia to the Americas, offering a linguistic trail that complements archaeological and genetic evidence. In another case, researchers have noted similarities between some African languages and those of the Andaman Islands in the Bay of Bengal. This unexpected connection has led to theories of ancient seafaring capabilities and long-distance migrations that were previously thought impossible for prehistoric humans. Such linguistic links challenge our understanding of early human travel and cultural diffusion. Linguistic similarities also support theories of prehistoric trade networks and cultural exchanges. Shared words for specific technologies or crops can indicate the spread of innovations across vast distances. For instance, similarities in terms related to agriculture and domesticated animals across Europe and parts of Asia suggest the movement of farming knowledge in prehistoric times. These linguistic clues help reconstruct ancient patterns of human interaction and technological diffusion, offering a window into the complex web of prehistoric global connections. Ancient trade routes were far more than mere paths for exchanging goods. They served as vital arteries for the flow of ideas, knowledge, and technological advancements across vast distances and diverse cultures. These networks, such as the famous Silk Road connecting China to the Mediterranean, facilitated the exchange of scientific discoveries, philosophical concepts, and practical innovations that shaped the course of human civilization. As merchants traversed these routes, they carried with them not just exotic spices and precious metals, but also books, instruments, and new techniques. The spread of papermaking from China to the Islamic world and eventually to Europe is a prime example of how trade routes facilitated technological diffusion. Similarly, Indian mathematical concepts, including the numeral system we use today, traveled westward along these paths, revolutionizing mathematics and commerce. These routes also enabled the exchange of agricultural knowledge and crops. Plants like cotton, sugarcane, and citrus fruits were introduced to new regions, transforming local economies and diets. Medical knowledge flowed along these same paths, with healers sharing remedies and techniques that blended traditions from different parts of the world. Perhaps most importantly, these trade routes fostered cultural exchange and understanding. Travelers returned home with new perspectives, religious ideas, and artistic styles, enriching their own societies and sparking innovation. The constant flow of people and ideas along these ancient highways created a network of knowledge that laid the foundation for many of the scientific and cultural achievements we benefit from today. Identical architectural features found in distant locations often provide compelling evidence of cultural exchange and interconnectedness between ancient civilizations. These shared design elements can reveal fascinating insights into the spread of ideas, technologies, and artistic styles across vast distances and through time. When we observe strikingly similar architectural motifs or construction techniques in structures separated by thousands of miles, it suggests that knowledge and expertise were shared through trade routes, migration, or even conquest. For example, the presence of step pyramids in both ancient Egypt and Mesoamerica has led researchers to explore possible connections between these geographically distant cultures. Such architectural similarities can also indicate the existence of widespread cultural or religious influences. The spread of Buddhist architecture from India to Southeast Asia and beyond demonstrates how spiritual beliefs can shape the built environment across diverse regions. Shared features like stupas, pagodas, and specific decorative elements trace the path of Buddhist expansion and adaptation in different societies. However, it is important to note that similar architectural features do not always imply direct contact between civilizations. In some cases, parallel development or convergent evolution of ideas can lead to comparable solutions to similar problems. Nonetheless, the study of architectural similarities remains a valuable tool for understanding the complex web of interactions that have shaped human cultures throughout history. Ancient seafaring has long captivated historians and archaeologists, with mounting evidence suggesting extensive transoceanic travel occurred well before officially recorded history. One compelling piece of evidence comes from genetic studies of sweet potatoes, which originated in South America, but were found throughout Polynesia when European explorers first arrived. This suggests Polynesian sailors likely reached South America and brought the crop back with them centuries before Columbus. Archaeological findings also support early transoceanic voyages. Artifacts discovered in South America show striking similarities to those found in Egypt and other parts of the ancient Mediterranean world, hinting at possible contact across the Atlantic Ocean thousands of years ago. Similarly, certain tools and pottery styles found in North America bear resemblance to those from ancient Japan, indicating potential Pacific crossings. Linguistic studies provide another intriguing avenue of evidence. Some researchers have identified surprising similarities between certain Native American languages and those spoken in parts of Eurasia, suggesting possible ancient connections across vast oceans. While these linguistic links remain controversial, they add to the growing body of evidence for pre-Columbian transoceanic contact. Perhaps most tantalizing are the ancient maps that seem to depict lands unknown to their supposed creators. The Piri Reis map, drawn in 1513, appears to show parts of South America and possibly Antarctica with surprising accuracy, despite being created decades before these regions were officially discovered by Europeans. Such cartographic anomalies fuel speculation about forgotten voyages and lost knowledge from our distant past. Ancient maps offer a fascinating glimpse into how our ancestors viewed and understood the world around them. These historical artifacts challenge our assumptions about early geographical knowledge in surprising ways. Cartographers from civilizations like ancient Greece, Rome, and China created maps that were remarkably accurate in some respects, despite lacking modern surveying tools or satellite imagery. For instance, Ptolemy's world map from the 2nd century CE showed a good understanding of the Mediterranean region and parts of Asia, though it contained significant errors in scale and proportion. What truly challenges our understanding is the occasional inclusion of unexpectedly accurate details on some ancient maps. The Piri Reis map, created in 1513, depicts parts of the South American coastline with surprising precision, leading some researchers to speculate about undocumented early explorations. Similarly, some medieval European maps show hints of knowledge about the Americas long before Columbus's voyage. These ancient cartographic works also reveal how different cultures conceptualized space and geography. Chinese maps, for example, often place China at the center of the world, reflecting their worldview. This reminds us that maps are not just records of geographical knowledge, but also cultural artifacts that embody the beliefs and perspectives of their creators. Shared agricultural practices across continents offer intriguing insights into ancient connections between distant civilizations. These similarities suggest that early human societies may have had more contact and exchange than previously thought, even across vast oceans and landmasses. One striking example is the cultivation of maize, or corn, which originated in Mexico but spread rapidly throughout the Americas and eventually to other parts of the world. The techniques used to grow and harvest maize were remarkably similar in regions separated by thousands of miles, indicating a possible transfer of knowledge or even direct contact between ancient peoples. Similarly, the development of terraced farming techniques can be found in various parts of the world, from the Andes Mountains in South America to the rice paddies of Southeast Asia. While these practices may have evolved independently in response to similar environmental challenges, the parallels in design and implementation raise questions about potential ancient connections or shared origins of agricultural knowledge. The domestication of certain crops and animals also shows surprising consistencies across continents. For instance, the methods used to cultivate and process wheat in the Middle East bear resemblances to those employed in parts of Asia and Europe. These shared practices suggest that ancient peoples may have exchanged ideas and techniques through trade networks or migrations that spanned greater distances than previously believed. The recurring appearance of similar religious symbols and concepts across diverse cultures has long intrigued scholars and researchers. This phenomenon suggests the possibility of a common source or shared human experience that transcends geographical boundaries and historical periods. One explanation for these similarities is the concept of archetypes, universal patterns or motifs that appear in the collective unconscious of humanity. These archetypes might manifest in various cultures as similar symbols, myths, or religious ideas, reflecting common human experiences and psychological needs. Another perspective considers the role of ancient cultural diffusion. As early human populations migrated across continents, they may have carried with them core religious concepts and symbols, which then evolved and adapted to new environments. This could explain why certain fundamental ideas, such as creation myths or flood stories, appear in numerous cultures worldwide. Cognitive scientists propose that the human brain's structure and function might predispose us to certain types of religious thinking and symbolism. Our shared cognitive architecture could lead different cultures to independently develop similar religious concepts as they grapple with existential questions and seek to understand the world around them. Throughout history, humans have created remarkable technologies that have been lost to time. One intriguing example is Roman concrete, used to build structures like the Pantheon in Rome. This ancient material has proven more durable than modern concrete, lasting for millennia and even strengthening over time. Despite extensive research, scientists have not fully replicated its exact composition and properties. Another lost technology is Damascus steel, renowned for its distinctive wavy pattern and exceptional strength. Swords made from this steel were said to be capable of cutting through other metal weapons. The specific technique for creating Damascus steel was lost around the 18th century, and modern attempts to recreate it have not fully captured its legendary qualities. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, represents a level of mechanical complexity that was not seen again for centuries. This ancient Greek analog computer could predict astronomical positions and eclipses with remarkable accuracy. While we understand its function, the knowledge required to design and build such a device in ancient times remains a mystery. Greek fire, a combustible liquid used in naval battles by the Byzantine Empire, is another lost technology. This substance could burn on water and was said to be nearly impossible to extinguish. Despite numerous theories, its exact composition remains unknown, leaving historians and scientists puzzled by its formidable capabilities. Ancient medical practices reveal a surprising depth of knowledge and sophistication that often challenges our modern assumptions about past scientific understanding. The ancient Egyptians, for instance, developed complex surgical techniques and a detailed understanding of human anatomy thousands of years ago. They performed brain surgery and were aware of the heart's role in blood circulation long before these concepts were rediscovered in Europe. In ancient Greece, Hippocrates laid the foundations for modern medical ethics and the importance of careful observation in diagnosing illnesses. His approach to medicine as a rational, evidence-based practice was revolutionary for its time and continues to influence medical thinking today. Chinese traditional medicine, with its holistic approach to health and detailed understanding of the human body's energy systems, offers insights that modern medicine is only now beginning to appreciate fully. Techniques like acupuncture, long dismissed by Western science, are now recognized as effective treatments for certain conditions. These ancient practices demonstrate that our ancestors were far from primitive in their understanding of the human body and health. They developed sophisticated systems of diagnosis and treatment based on careful observation and centuries of accumulated knowledge. This realization challenges us to approach ancient wisdom with greater respect and openness, recognizing that there may still be valuable insights to be gained from studying these time-tested practices. Throughout history, there have been remarkable examples of metallurgical expertise that have puzzled modern scientists and archaeologists. One of the most intriguing cases is that of Damascus steel, renowned for its distinctive watery or wavy pattern and exceptional strength. This legendary metal was used to forge swords of unparalleled quality from the 3rd to the 17th centuries. Despite numerous attempts, modern metallurgists have been unable to fully replicate the exact techniques used to create authentic Damascus steel. Another fascinating example is the Pillar of Delhi in India, an iron column that has stood for over 1,500 years without significant corrosion. The pillar's resistance to rust has baffled experts, as iron typically oxidizes rapidly, especially in humid conditions. Some theories suggest that a protective layer of misoite, a crystalline iron-hydrogen phosphate, formed on the pillar's surface, but the exact method of its creation remains a mystery. The Incas demonstrated advanced metallurgical skills that have yet to be fully understood. They developed a technique to create gold and silver alloys that appeared to change color when viewed from different angles. This process, known as depletion gilding, involved selectively removing certain metals from the surface of an alloy, creating a complex, layered structure that modern metallurgists are still working to comprehend fully. These examples highlight the existence of sophisticated metallurgical knowledge in ancient civilizations that has been lost over time. While modern science continues to make strides in understanding these techniques, the full extent of this ancient expertise remains elusive, reminding us that technological progress is not always linear and that valuable knowledge can be lost to the ages. Ancient astronomical devices reveal a remarkable level of scientific sophistication that often surprises modern observers. These intricate instruments, crafted thousands of years ago, showcase our ancestors' deep curiosity about the cosmos and their ingenious methods for tracking celestial movements. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, stands as a testament to ancient Greek astronomical knowledge. This complex geared device, dating back to around 150 BCE, could predict solar and lunar eclipses, track the positions of planets, and even account for the irregular orbit of the moon. Its precision and complexity rival that of clockwork mechanisms developed over a millennium later. In Mesoamerica, the Maya constructed elaborate observatories and developed a highly accurate calendar system. Their understanding of Venus's movements was so precise that they could predict its appearances and disappearances over a span of centuries. This level of astronomical knowledge influenced Maya architecture, with some structures aligned to mark important celestial events. Ancient Chinese astronomers created sophisticated instruments like the armillary sphere, which modeled celestial objects' movements. These devices demonstrated a deep understanding of the night sky and were used for both practical timekeeping and imperial divination. The precision of ancient Chinese astronomical observations led to the recording of phenomena like supernovas, centuries before they were documented in the West. Ancient civilizations developed remarkable chemical processes that continue to baffle modern scientists. One intriguing example is the creation of Damascus steel, a legendary metal known for its distinctive wavy pattern and exceptional strength. Despite centuries of effort, metallurgists have yet to fully replicate the exact techniques used to forge these blades. Another perplexing ancient chemical process is the production of Roman concrete. This durable material has withstood the test of time, lasting for millennia in harsh marine environments where modern concrete would crumble within decades. The secret to its longevity lies in its unique chemical composition, which allows it to become stronger over time through a process called mineral crystallization. The vibrant blue pigment known as Maya blue presents another chemical mystery. This vivid color, used in Mesoamerican art and architecture, has maintained its brilliance for over 1,000 years. Scientists have only recently begun to unravel the complex nanotechnology behind its creation, which involves a combination of indigo dye and a clay mineral called palygorskite. Egyptian blue, the world's oldest known synthetic pigment, is yet another example of ancient chemical ingenuity. While we now understand its basic composition, the exact techniques used to consistently produce this stable, vivid blue color in ancient times remain elusive. These enduring mysteries highlight the sophisticated knowledge and skills of our ancestors, challenging our assumptions about the linear progress of scientific understanding. Ancient civilizations left behind remarkable structures that demonstrate a sophisticated understanding of acoustics, hinting at knowledge that was later forgotten. The Great Ball Court at Chichen Itza in Mexico is a prime example. This massive Mayan structure exhibits extraordinary acoustic properties. A person speaking at one end can be clearly heard at the other end, nearly 500 feet away, despite the open-air setting. This effect, known as the Whispering Gallery, suggests the Mayans possessed advanced acoustic engineering skills. In ancient Greece, the theater of Epidaurus stands as a testament to acoustic mastery. Built in the 4th century BCE, this open-air theater can seat up to 14,000 people. Yet even those in the back row can hear a whisper from the stage. The precise arrangement of limestone seats acts as a natural audio filter, enhancing sounds within the range of human speech while dampening background noise. Halfway across the world, the Chavín de Huántar temple complex in Peru reveals another facet of ancient acoustic knowledge. This site features underground chambers and passageways designed to amplify and distort sound. Researchers believe these acoustic effects were used in religious ceremonies to create an otherworldly atmosphere, possibly inducing altered states of consciousness in participants. These examples, spanning different continents and cultures, suggest that our ancestors had a deep understanding of sound manipulation. This knowledge appears to have been largely lost or forgotten over time, only to be rediscovered and explained by modern science. The existence of such structures raises intriguing questions about the extent of ancient scientific understanding and the potential for lost technologies waiting to be uncovered. Ancient civilizations demonstrated remarkable navigation skills long before the advent of modern technology. The Polynesians, for instance, mastered the art of wayfinding, using their knowledge of ocean currents, wind patterns, and celestial bodies to navigate vast stretches of the Pacific Ocean. They developed intricate stick charts to map wave patterns and island locations, enabling them to voyage thousands of miles between distant islands. In the Mediterranean, the Phoenicians were renowned sailors who navigated by the stars and likely used early forms of the sextant to determine their latitude. Archaeological evidence suggests they circumnavigated Africa as early as 600 BCE, a feat that required exceptional navigational prowess. The Vikings, too, displayed advanced navigation techniques. They used a device called a sunstone, believed to be a piece of calcite crystal, which could determine the position of the sun even on cloudy days. This allowed them to maintain accurate headings during their long sea voyages across the North Atlantic. Perhaps most impressively, the ancient Polynesians reached Hawaii and Easter Island, incredibly remote locations, without the aid of modern navigational tools. Their ability to traverse such vast oceanic distances speaks to a sophisticated understanding of celestial navigation, ocean currents, and the behavior of migratory birds and marine life. Ancient texts from various cultures contain descriptions of technologies that appear far beyond the capabilities of their era. The Vimanas mentioned in ancient Indian texts, for example, describe flying machines with astonishing abilities. These craft were said to move in any direction, travel vast distances, and even journey between planets. Greek and Roman writers also describe devices that seem out of place in ancient times. Hero of Alexandria wrote about a steam-powered device called an aeolipile, which resembles a primitive steam engine. This invention, dating back to the 1st century, was far ahead of its time but never developed into practical technology. In ancient Egyptian hieroglyphs, some researchers claim to have found depictions of what appear to be electric light bulbs and other advanced devices. While these interpretations are highly controversial, they continue to intrigue both scholars and the public. Similarly, some ancient Mesopotamian texts describe what some interpret as advanced weaponry or energy sources. These accounts raise fascinating questions about the knowledge and capabilities of ancient civilizations. While some researchers suggest these texts might indicate forgotten advanced technologies or even extraterrestrial influences, most scholars attribute them to imaginative storytelling, misinterpretations of metaphorical language, or exaggerated accounts of existing technologies. Regardless of their origin, these descriptions continue to captivate our imagination and fuel debates about the true extent of ancient knowledge. The Antikythera mechanism, an ancient Greek device discovered in a shipwreck, has fascinated scientists and historians for decades. This complex bronze gear system, dating back to around 150 to 100 BC, is often considered the world's first analog computer. One prominent theory suggests that the Antikythera mechanism was used as an astronomical calculator. It could predict celestial events such as eclipses and track the movements of planets with remarkable accuracy. This function would have been invaluable for ancient astronomers and possibly for religious purposes, as celestial events often held great significance in Greek culture. Another theory proposes that the device served as a sophisticated calendar. It could track the 4-year cycle of the Olympic Games and other important Greek festivals. This would have been crucial for timekeeping and planning in the ancient world, where precise long-term calendars were not widely available. Some researchers believe the Antikythera mechanism might have had practical applications in navigation. By accurately predicting the positions of celestial bodies, it could have aided sailors in determining their location at sea. This theory aligns with the device's discovery in a shipwreck, suggesting it may have been a valuable tool for maritime trade and exploration. Ancient batteries, such as the Baghdad battery, present a fascinating puzzle that challenges our conventional understanding of technological progress. Discovered in 1938 near Baghdad, Iraq, this artifact consists of a clay jar containing a copper cylinder and an iron rod. When filled with an acidic liquid like vinegar, it could potentially generate a small electric current. The existence of such a device, dating back to the Parthian period between 250 BCE and 224 CE, raises intriguing questions about the extent of ancient knowledge regarding electricity. If the Baghdad battery indeed functioned as an electrochemical cell, it would predate the official discovery of electricity by Alessandro Volta in 1800 by nearly 2,000 years. This discovery suggests that some ancient civilizations might have possessed a rudimentary understanding of electrical phenomena long before the modern era. It forces us to reconsider our assumptions about the linear progression of scientific knowledge and technological advancement. The Baghdad Battery hints at the possibility that there were pockets of advanced understanding in the ancient world that were subsequently lost or forgotten over time. However, the purpose and actual use of the Baghdad Battery remains subjects of debate among historians and archaeologists. Some theories propose it was used for electroplating, pain relief, or religious ceremonies, while others argue it might have been a simple storage vessel. Regardless of its true function, the Baghdad Battery serves as a reminder that the path of human innovation is far more complex and nuanced than we often assume, with potential leaps in understanding occurring at unexpected points in history. Recent underwater archaeological discoveries have revealed several fascinating submerged cities, offering glimpses into ancient civilizations lost to rising sea levels. One notable find is Pavlopetri, located off the coast of southern Greece. This Bronze Age settlement, dating back approximately 5,000 years, provides valuable insights into early urban planning and maritime trade in the Mediterranean. In the Gulf of Cambay, off the western coast of India, researchers have uncovered the remains of a vast city believed to be over 9,000 years old. This discovery challenges our understanding of the timeline of urban development in the region and suggests a more advanced civilization existed there much earlier than previously thought. The sunken city of Heraklion, also known as Thonis, was discovered in 2001 in Egypt's Abu Qir Bay. Once a thriving port city, Heraklion vanished beneath the waves over 1,000 years ago. Divers have recovered numerous artifacts, including colossal statues, gold coins, and the remains of over 60 ships, painting a vivid picture of life in this ancient Egyptian metropolis. Another remarkable find is Port Royal in Jamaica, often referred to as the real-life Atlantis of the Caribbean. This 17th-century pirate haven was submerged by an earthquake in 1692. The underwater ruins provide an unparalleled snapshot of life in a bustling colonial port, with buildings, streets, and everyday objects frozen in time beneath the waves. Underwater archaeology opens a remarkable window into the past, revealing secrets of ancient civilizations that have long been hidden beneath the waves. This specialized field allows researchers to explore sunken cities, shipwrecks, and submerged landscapes that have been preserved in ways impossible on land. The underwater environment often acts as a time capsule, protecting artifacts and structures from decay and destruction. In the absence of oxygen and light, many materials remain intact for thousands of years, providing archaeologists with a wealth of well-preserved evidence. This includes organic materials like wood, textiles, and even food remnants that would typically disintegrate in terrestrial sites. Underwater excavations have uncovered entire cities lost to rising sea levels or natural disasters. These submerged urban centers offer unparalleled insights into daily life, architecture, and societal structures of ancient civilizations. For example, the sunken portions of Alexandria in Egypt have revealed intricate palace complexes and monumental statues, shedding light on the grandeur of the Ptolemaic dynasty. Shipwrecks serve as invaluable time capsules, capturing a specific moment in history. The cargo, personal belongings, and the vessels themselves provide detailed information about trade routes, technological advancements, and cultural exchanges between different civilizations. By studying these underwater sites, archaeologists can piece together complex networks of commerce and communication that shaped ancient societies, offering a unique perspective on how our ancestors interacted with the world around them. Researchers exploring underwater sites encounter numerous challenges that test their skills and technology. The ocean's immense pressure poses a significant obstacle, increasing dramatically with depth and requiring specialized equipment to withstand these extreme conditions. Even with advanced gear, divers can only descend to limited depths before risking dangerous effects like nitrogen narcosis or decompression sickness. Visibility presents another major hurdle in underwater exploration. Murky waters, stirred-up sediment, and lack of natural light can severely restrict a diver's field of view, making it difficult to navigate, document findings, or locate specific targets. Researchers often rely on powerful artificial lights and sophisticated sonar equipment to overcome these visibility issues. The corrosive nature of saltwater also complicates underwater research. It can quickly damage sensitive equipment and degrade historical artifacts, necessitating careful planning and protective measures. Additionally, strong currents and unpredictable weather patterns can make dive operations hazardous, limiting the time researchers can spend at a site and potentially compromising safety. Lastly, the sheer vastness of the underwater world poses a challenge. With much of the ocean floor still unmapped and unexplored, locating specific sites of interest can be like finding a needle in a haystack. This requires extensive preliminary research, advanced mapping techniques, and often a bit of luck to make significant discoveries in the depths of our oceans. Sunken artifacts serve as invaluable time capsules, offering a wealth of information about ancient maritime trade routes. These submerged treasures, preserved by the ocean depths, provide archaeologists and historians with tangible evidence of past commercial activities and cultural exchanges. When ships sank centuries ago, they often took their entire cargo to the seafloor. This cargo, ranging from pottery and coins to raw materials and luxury goods, offers a snapshot of what was being traded at the time. By studying the origin and distribution of these artifacts, researchers can piece together the complex web of trade routes that crisscrossed ancient seas. The location of shipwrecks themselves is crucial in mapping these routes. Clusters of wrecks in certain areas can indicate popular shipping lanes or treacherous waters that posed risks to ancient mariners. Additionally, the construction techniques and materials used in shipbuilding can reveal the origin of vessels and the extent of technological exchange between different cultures. Analysis of organic materials found in sunken ships, such as food remains or wooden objects, can provide insights into the types of goods transported and the duration of voyages. This information, combined with historical records and land-based archaeological findings, allows researchers to reconstruct a comprehensive picture of ancient maritime trade networks, shedding light on the economic and cultural connections that shaped early civilizations. Underwater archaeology has revealed fascinating evidence of advanced ancient harbor engineering in various parts of the world. Off the coast of Alexandria, Egypt, divers have discovered the remnants of an extensive harbor complex dating back to the Ptolemaic period, over 2,000 years ago. This complex included massive stone blocks and intricate breakwaters designed to protect ships from rough seas. In the Mediterranean, the submerged ruins of Caesarea Maritima showcase the engineering prowess of ancient Rome. Built under Herod the Great, this harbor featured innovative concrete structures that could set underwater, a technology lost for centuries after the fall of the Roman Empire. The harbor's design included a series of interconnected breakwaters and quays, demonstrating a sophisticated understanding of hydrodynamics. More recent discoveries in the Gulf of Corinth, Greece, have uncovered an elaborate system of underwater structures believed to be part of the ancient port of Lechaeon. These findings include well-preserved wooden caissons filled with concrete-like materials, suggesting advanced construction techniques that allowed for the creation of large, stable harbor structures in challenging marine environments. These underwater discoveries not only provide evidence of the engineering capabilities of ancient civilizations, but also offer insights into historical trade routes, naval technology, and the economic importance of maritime commerce in the ancient world. As underwater exploration techniques continue to advance, it's likely that more evidence of ancient harbor engineering will come to light, further expanding our understanding of these remarkable achievements. Submerged structures have revolutionized our understanding of sea level changes and their profound effects on ancient civilizations. These underwater remnants, ranging from sunken cities to submerged roads and buildings, provide tangible evidence of how dramatically our coastlines have shifted over millennia. One striking example is the discovery of Pavlopetri, an ancient Greek city now lying beneath the waters off the coast of southern Laconia. This underwater site, dating back to the Bronze Age, offers a glimpse into a thriving maritime community that existed over 4,000 years ago. Its submergence tells us that sea levels in this region have risen by several meters since the city was inhabited, forcing its residents to abandon their homes and move inland. These submerged structures also challenge our previous assumptions about the rate and extent of sea level rise. In some cases, they reveal that changes occurred more rapidly or to a greater degree than we had initially believed. For instance, studies of submerged Neolithic villages in the Black Sea suggest that sea levels rose dramatically and quickly, possibly due to a catastrophic flood event that inundated vast areas of coastal land. Furthermore, these underwater discoveries highlight the resilience and adaptability of ancient civilizations in the face of changing environments. They show us how our ancestors responded to rising seas, sometimes by building elaborate flood defenses, other times by gradually retreating to higher ground. This knowledge is particularly relevant today as we grapple with the challenges posed by current and future sea level rise due to climate change. The past decade has seen remarkable advancements in underwater archaeology, revealing fascinating insights into our maritime history. One of the most significant discoveries was the location of the HMS Erebus in 2014, followed by the HMS Terror in 2016. These ships, part of the ill-fated Franklin expedition, had been lost in the Arctic for over 160 years. Their discovery has provided valuable information about 19th-century polar exploration and the fate of the expedition's crew. Another noteworthy find was the ancient Egyptian city of Thonis Heracleion, rediscovered off the coast of Alexandria. This submerged metropolis, once a vital trading hub, has yielded a treasure trove of artifacts, including colossal statues, gold coins, and the remains of over 60 ships. The excavation of this site has greatly enhanced our understanding of ancient Egyptian maritime trade and urban planning. In the Black Sea, researchers uncovered an astonishingly well-preserved shipwreck dating back over 2,400 years. The ancient Greek trading vessel, found in 2018, was so intact that even the mast and rowing benches were still in place. This remarkable preservation was due to the Black Sea's oxygen-free deep waters, offering archaeologists an unprecedented glimpse into ancient seafaring techniques. Closer to modern times, the discovery of the wreck of the USS Indianapolis in 2017 marked a significant moment in naval history. The cruiser, sunk by a Japanese submarine in the final days of World War II, was found more than 5,000 meters deep in the Philippine Sea. This discovery not only provided closure for the families of the ship's crew, but also offered new insights into one of the most tragic naval disasters in United States history. Underwater excavations provide archaeologists with invaluable insights into ancient shipbuilding techniques, offering a unique window into the maritime past. When ships sink and settle on the ocean floor, they often become naturally preserved in sediment, protecting them from decay and maintaining their structural integrity for centuries or even millennia. These submerged time capsules allow researchers to study the intricate details of ship construction that would otherwise be lost to history. By carefully excavating and documenting these wrecks, archaeologists can examine the types of wood used, the methods of joining planks, and the overall design of the vessel. They can observe how the ship was framed, how the hull was shaped, and what materials were used for caulking and waterproofing. Moreover, underwater excavations often reveal tools, fasteners, and other artifacts associated with shipbuilding. These items provide further clues about the techniques and technologies available to ancient shipwrights. By analyzing these findings, researchers can reconstruct the step-by-step process of how these vessels were built, from the initial laying of the keel to the final outfitting. The information gleaned from underwater excavations allows historians and naval architects to create detailed reconstructions of ancient ships. These reconstructions not only enhance our understanding of maritime history, but also shed light on ancient trade routes, naval warfare, and the technological capabilities of past civilizations. Through careful study of these sunken treasures, we continue to unravel the mysteries of how our ancestors mastered the art of shipbuilding and conquered the seas. Marine geology serves as a crucial tool in the quest to uncover hidden treasures beneath the waves. By studying the seafloor's composition and structure, Marine geologists provide archaeologists with valuable insights into potential underwater archaeological sites. The shape and makeup of the seabed can offer clues about past civilizations and sunken artifacts. For instance, certain geological formations might indicate ancient coastlines or submerged river valleys, areas where human settlements once thrived before sea levels rose. These underwater landscapes can guide archaeologists to promising locations for further investigation. Sediment analysis also plays a key role in this process. Marine geologists examine layers of sediment to determine how they've accumulated over time, which can help date potential archaeological sites. They can identify areas where sediment has built up slowly, preserving artifacts, or regions where strong currents might have exposed or moved historical objects. Furthermore, marine geology helps identify underwater hazards and challenges that archaeologists might face during excavations. This information is vital for planning safe and effective underwater archaeological expeditions, ensuring that valuable historical artifacts can be recovered and studied without damaging the site or endangering the research team. Underwater archaeological sites offer a treasure trove of preserved organic materials that provide remarkable insights into our past. The oxygen-poor environments found in many submerged locations create ideal conditions for preserving items that would typically decay rapidly on land. These waterlogged environments often prevent the growth of bacteria and fungi that normally break down organic matter, allowing archaeologists to recover artifacts made from wood, leather, textiles, and even food remains. These preserved materials offer a rare glimpse into the daily lives of ancient people, revealing details about their diet, clothing, tools, and living conditions that might otherwise be lost to time. For example, shipwrecks can yield intact wooden ship structures, ropes, and personal belongings of crew members, providing valuable information about naval technology, trade routes, and maritime life in different historical periods. In some cases, underwater sites have preserved entire settlements, such as those submerged due to rising sea levels or geological events. These sites can offer a snapshot of life frozen in time, with household items, structures, and even human remains preserved in remarkable detail. The anaerobic conditions in underwater environments can also preserve DNA, allowing researchers to study the genetic makeup of ancient populations and trace their migrations and relationships to modern groups. The unique preservation qualities of underwater sites extend beyond physical artifacts to include environmental data. Sediment cores from submerged areas can contain pollen, plant remains, and other organic materials that provide insights into past climates, vegetation patterns, and human impact on the environment. This wealth of information from underwater sites helps archaeologists and historians paint a more complete picture of human history and our relationship with the natural world. Ancient civilizations developed remarkable methods to track celestial movements, displaying ingenuity that still impresses us today. Their motivations were both practical and spiritual, as the sky served as a calendar, a navigational tool, and a source of religious significance. One of the most common tools used by ancient astronomers was the gnomon, a vertical stick that cast shadows as the sun moved across the sky. By marking the length and direction of these shadows throughout the year, they could determine solstices, equinoxes, and even create rudimentary sundials. This simple yet effective method allowed for surprisingly accurate timekeeping and seasonal predictions. More complex structures, such as stone circles and monuments, were also used to track celestial events. The famous Stonehenge in England, for example, aligns with the summer solstice sunrise, suggesting its use as an astronomical calendar. Similarly, the Maya built observatories like the one at Chichen Itza, where windows and doorways lined up with specific astronomical events. Ancient civilizations also created detailed star charts and catalogues. The Babylonians, for instance, recorded the movements of planets and stars on clay tablets, while the ancient Chinese developed elaborate systems to predict celestial events. These early astronomers' dedication to observing and recording the night sky over generations led to increasingly precise predictions, laying the groundwork for modern astronomy. Ancient astronomical alignments offer fascinating insights into the scientific understanding of our ancestors. These structures, found across various cultures and continents, demonstrate a sophisticated grasp of celestial movements and cycles. Many ancient cultures built monuments and structures aligned with celestial events like solstices, equinoxes, and the movements of specific stars. The Great Pyramid of Giza in Egypt, for instance, is precisely aligned with the cardinal directions, showcasing the ancient Egyptians' advanced surveying and engineering skills. Stonehenge in England is famously aligned with the summer solstice sunrise, revealing the builder's ability to track and predict seasonal changes. These alignments required careful observation and record-keeping over extended periods, sometimes spanning generations. This long-term dedication to astronomical study indicates that ancient civilizations recognized the importance of understanding celestial patterns for practical purposes such as agriculture, navigation, and timekeeping. Moreover, these structures reveal that ancient peoples possessed mathematical and geometrical knowledge far beyond what was previously assumed. The precision of many alignments suggests an understanding of complex concepts like the precession of the equinoxes, which takes nearly 26,000 years to complete one cycle. This level of astronomical knowledge challenges our perceptions of ancient scientific capabilities and encourages us to re-evaluate the depth of their understanding of the cosmos. Ancient calendars reveal a remarkable grasp of celestial movements, showcasing our ancestors' keen observational skills and mathematical prowess. These early timekeeping systems, often aligned with lunar phases, solar events, and even the motion of planets, demonstrating a deep connection between human activities and cosmic rhythms. The Mayan calendar, for instance, tracked Venus with astonishing accuracy. Its complex system of interlocking cycles not only marked the planet's visible appearances, but also predicted its movements far into the future. This level of precision required centuries of careful observation and calculation, highlighting the dedication of ancient astronomers to understanding the cosmos. In Mesopotamia, the Babylonians developed a lunar calendar that formed the basis for many modern timekeeping systems. They divided the year into 12 months, each beginning with the first sighting of the new moon. To reconcile the lunar year with the solar year, they ingeniously added an extra month every few years, a practice still used in some cultures today. The ancient Egyptians created one of the first solar calendars, basing their year on the annual flooding of the Nile River, which coincided with the heliacal rising of Sirius, the brightest star in the night sky. This alignment of celestial and terrestrial events demonstrates how early civilizations integrated astronomical knowledge into their daily lives, using the sky as both clock and calendar. Ancient civilizations had remarkable knowledge of the cosmos, but evidence for their awareness of planets beyond those visible to the naked eye is limited and often debated. The planets Mercury, Venus, Mars, Jupiter, and Saturn were well known to many ancient cultures, as these can be seen without telescopes. However, some intriguing artifacts and texts hint at possible knowledge of outer planets. One fascinating example comes from ancient Mesopotamia. Sumerian texts mention a celestial body called Nibiru, which some researchers have speculated could refer to a planet beyond Saturn. However, mainstream scholars generally interpret Nibiru as referring to Jupiter or another known celestial object, rather than an undiscovered planet. In ancient India, some Vedic texts describe a cosmic order with 7 celestial bodies, which some interpret as including Uranus. However, this interpretation is highly contested, and most experts believe these texts refer to the known, visible planets and other celestial objects. Perhaps the most tantalizing evidence comes from the Antikythera mechanism, an ancient Greek astronomical device. This complex machine tracks the movements of celestial bodies with remarkable accuracy. Some researchers have suggested that certain gears in the mechanism might correspond to the orbit of planets like Uranus, but this remains speculative. While these examples are intriguing, they fall short of conclusive proof that ancient civilizations had knowledge of planets invisible to the naked eye. Ancient cosmological models were vastly different from our current understanding of the universe. Early civilizations often viewed Earth as the center of everything, with celestial bodies revolving around it. The ancient Greeks, for instance, developed a geocentric model where the sun, moon, planets, and stars were thought to be embedded in crystalline spheres rotating around Earth. This Earth-centered view persisted for centuries, with refinements like the Ptolemaic system adding complex circular motions to explain observed planetary movements. However, these models were based on limited observations and philosophical assumptions rather than scientific evidence. Our modern understanding of the universe began to take shape with the Copernican revolution in the 16th century. Copernicus proposed a heliocentric model, placing the sun at the center of the solar system. This radical shift in perspective was further developed by Galileo, Kepler, and Newton, laying the groundwork for our current cosmic view. Today, we know the universe is vastly larger and more complex than ancient models ever imagined. We understand that Earth is one of several planets orbiting the Sun, which is just one of hundreds of billions of stars in the Milky Way galaxy. Our galaxy, in turn, is one among billions in an expanding universe that began with the Big Bang nearly 14 billion years ago. This modern cosmology, supported by advanced observations and rigorous scientific methods, reveals a universe far grander and more awe-inspiring than our ancestors could have conceived. Throughout history, humans have gazed at the stars and built structures to study celestial movements. One of the most famous examples is Stonehenge in England, constructed over 5,000 years ago. This circular arrangement of massive stones aligns with the summer solstice sunrise, suggesting its use for tracking seasonal changes and celestial events. In Central America, the Maya built impressive structures for astronomical observations. The El Caracol Observatory at Chichen Itza in Mexico features a circular tower with windows precisely aligned to track the movements of Venus. This advanced design allowed Maya astronomers to predict Venus's appearance in the night sky with remarkable accuracy. Halfway across the world, in India, the Jantar Mantar complex in Jaipur stands as a testament to astronomical ingenuity. Built in the 18th century, this collection of 19 architectural instruments includes enormous sundials and structures for tracking stars and planets. The precision of these instruments is so high that they can measure time to within 2 seconds. In South America, the Incas constructed Machu Picchu with careful astronomical considerations. The Intihuatana stone at this ancient city acts as a precise indicator of the 2 annual equinoxes. When the sun stands directly above the pillar, it casts no shadow, marking these important dates in the Incan calendar. Ancient civilizations developed sophisticated methods to predict eclipses and celestial events through careful observation and record-keeping. The Babylonians, for instance, discovered the Saros cycle, a period of approximately 18 years after which lunar and solar eclipses repeat in a similar pattern. This knowledge allowed them to anticipate future eclipses with remarkable accuracy. In ancient China, astronomers created detailed star charts and catalogued celestial phenomena over centuries. They noticed recurring patterns in the movements of celestial bodies, enabling them to predict events like comets and planetary alignments. The Chinese also developed complex mathematical models to calculate the positions of heavenly objects. The Maya civilization of Central America constructed elaborate observatories and developed a highly accurate calendar system. Their astronomical calculations were so precise that they could predict solar eclipses and the movements of Venus centuries in advance. These predictions played a crucial role in their religious and agricultural practices. Ancient Greek astronomers, such as Hipparchus and Ptolemy, made significant contributions to predictive astronomy. They created mathematical models of planetary motion and developed tools like the astrolabe, which allowed for precise measurements of celestial positions. These advancements laid the foundation for future astronomical discoveries and predictions. Ancient star charts offer a fascinating glimpse into our ancestors' understanding of the cosmos. These early maps of the night sky, some dating back thousands of years, reveal a sophisticated grasp of celestial patterns and movements that might surprise modern observers. Many ancient cultures, from Babylonian astronomers to Chinese court astrologers, meticulously recorded the positions and movements of celestial bodies. These charts show that early sky watchers could predict celestial events with remarkable accuracy, including eclipses and the appearances of comets. They also demonstrate how different civilizations grouped stars into constellations, often reflecting their own mythologies and cultural beliefs. One of the most famous ancient star charts, the Dunhuang Star Atlas from China, dates back to about 950 CE. This detailed map shows over 1,300 stars and spans the entire northern sky visible from China. Its accuracy and comprehensiveness reveal that Chinese astronomers of the time possessed advanced observational skills and a deep understanding of celestial mechanics. These ancient charts not only showcase astronomical knowledge, but also highlight the practical applications of this wisdom. Many cultures used the stars for navigation, agricultural planning, and timekeeping. The ability to read the night sky was crucial for seafaring peoples, allowing them to undertake long voyages and expand trade routes. Thus, these star charts represent not just scientific achievement, but also the foundations of early global exploration and commerce. Ancient artifacts from various cultures around the world offer tantalizing hints that our ancestors may have possessed sophisticated knowledge of celestial events and cosmic phenomena long before the advent of modern astronomy. One intriguing example is the Antikythera mechanism, discovered in a shipwreck off the coast of Greece. This complex bronze device, dating back to around 150 BCE, was capable of predicting astronomical positions and eclipses with remarkable accuracy. Its intricate gears and dials reveal a deep understanding of celestial mechanics that was not thought to exist in the ancient world. In South America, the Incan site of Machu Picchu features structures aligned with solstices and other astronomical events. The Intihuatana stone, often called the hitching post of the sun, casts specific shadows that mark important dates in the Incan calendar. This suggests a sophisticated grasp of the sun's annual journey across the sky and its impact on seasonal changes. Halfway across the world, the Goseck Circle in Germany, dating back to 4,900 BCE, is one of the oldest known solar observatories. Its precisely aligned gates correspond to the rising and setting points of the sun during the winter solstice, indicating that Neolithic Europeans had detailed knowledge of solar movements thousands of years before the development of written astronomy. These artifacts challenge our assumptions about ancient knowledge and technological capabilities. They suggest that our ancestors were keen observers of the night sky, capable of complex calculations and engineering feats to track celestial movements. This ancient wisdom, encoded in stone and metal, continues to astonish modern scientists and historians, bridging the gap between our distant past and our current understanding of the cosmos. Astronomy played a crucial role in the development of ancient mathematics, serving as both a driving force and a practical application for mathematical concepts. Ancient civilizations, including the Babylonians, Egyptians, and Greeks, used astronomical observations to create calendars, predict celestial events, and navigate the seas. The need to accurately track the movements of celestial bodies led to the development of complex numerical systems and mathematical models. For instance, the Babylonians devised a sexagesimal number system based on the number 60, which is still used today in measuring time and angles. This system allowed for precise calculations of planetary positions and the prediction of eclipses. Geometry, too, owes much of its early development to astronomical studies. The ancient Greeks, in particular, used geometric models to explain the motions of planets and stars. This approach culminated in works like Ptolemy's Almagest, which presented a mathematical model of the universe that remained influential for over 1,000 years. Trigonometry, another fundamental branch of mathematics, emerged largely from the need to solve problems in astronomy. The study of triangles and their relationships proved essential for calculating distances to celestial objects and predicting their positions in the sky. These astronomical applications pushed mathematicians to develop increasingly sophisticated trigonometric functions and tables. Throughout the study of human evolution, scientists have occasionally encountered skeletal remains that challenge our existing knowledge. These puzzling discoveries often lead to new questions and theories about our ancestral past. One intriguing example is the so-called Denisovans, known primarily from a few bone fragments found in Siberia. These remains suggest the existence of a previously unknown human species that coexisted with Neanderthals and early modern humans. Another perplexing case is Homo floresiensis, nicknamed the Hobbit due to its small stature. Discovered on the Indonesian island of Flores, these remains depict a human species standing only about 3 feet tall, with a brain size comparable to that of a chimpanzee. This finding has sparked debates about whether Homo floresiensis represents a distinct species or a population of modern humans affected by a genetic condition. The Red Deer Cave people, whose fossils were found in China, present another conundrum. These remains, dating back to just 46,000 years ago, exhibit a unique combination of primitive and modern features that don't neatly fit into our current evolutionary timeline. Some researchers suggest they might represent a previously unknown species or a late surviving population of archaic humans. Lastly, the discovery of Homo naledi in South Africa has raised intriguing questions. These remains show a mix of primitive and modern traits, with a small brain but human-like hands and feet. The dating of these fossils to a surprisingly recent period has led to speculation about the coexistence of multiple human species and the complexity of our evolutionary journey. These examples highlight the ongoing nature of paleoanthropological research and the potential for new discoveries to reshape our understanding of human evolution. Elongated skulls discovered in different regions across the globe have sparked intense debate among archaeologists and historians, challenging our conventional understanding of human history. These unusual cranial shapes, found in ancient burial sites from Peru to Egypt, have led researchers to question long-held beliefs about early human societies and their practices. One of the most intriguing aspects of these elongated skulls is their uniformity across diverse cultures and geographic locations. This widespread occurrence suggests a potentially shared cultural practice or a common origin that spans continents, contradicting the idea of isolated civilizations developing independently. Some researchers propose that this could indicate previously unknown connections between ancient cultures or even suggest the possibility of a global civilization predating our current historical timeline. The methods used to achieve these elongated skull shapes also raise questions about the technological and medical knowledge of ancient societies. While some elongated skulls are the result of intentional cranial deformation, a practice involving binding infants' heads to alter their shape, others appear to be naturally occurring. This distinction has led to speculation about genetic factors or unknown human subspecies, further complicating our understanding of human evolution and migration patterns. Moreover, the purpose behind this practice remains a mystery, challenging our assumptions about ancient social structures and belief systems. Some theories suggest that elongated skulls were a mark of social status or religious significance, while others propose more practical reasons related to improved cognitive abilities or sensory perception. These hypotheses force us to reconsider the complexity and sophistication of ancient societies, potentially rewriting chapters of human history we thought were well understood. Genetic analysis of ancient human remains has revealed fascinating insights into our evolutionary past. One intriguing discovery is the presence of Neanderthal DNA in modern human genomes, indicating interbreeding between our species and our close relatives tens of thousands of years ago. This genetic legacy continues to influence traits in some populations today, including aspects of immune function and skin characteristics. Another significant finding comes from the analysis of Denisovan DNA, a distinct group of ancient humans first identified through genetic sequencing. Traces of Denisovan ancestry have been found in modern Melanesian populations, suggesting complex interactions between different human groups throughout history. Researchers have also uncovered genetic adaptations in ancient remains that shed light on human evolution. For instance, studies of bones from early European farmers revealed genetic changes associated with the ability to digest lactose into adulthood, a trait that became advantageous with the advent of dairy farming. More recent examinations have identified genetic variants linked to disease resistance. One notable example is a mutation that appears to have protected some ancient populations against the bubonic plague, providing valuable information about how humans have evolved in response to deadly pathogens over time. Fossil evidence from various parts of the world reveals a fascinating picture of human diversity in our ancient past. Discoveries of different hominin species, such as Homo floresiensis in Indonesia and Homo luzonensis in the Philippines, suggest that multiple human-like species coexisted at various points in history. These findings indicate that human evolution was not a simple, linear process, but rather a complex branching tree with numerous offshoots. The remains of Homo floresiensis, nicknamed the Hobbit due to its small stature, show that a distinct species of human relatives lived on the island of Flores until as recently as 50,000 years ago. This species exhibited unique features, including a small brain size and short height, which were likely adaptations to their island environment. Similarly, the discovery of Homo naledi in South Africa presents another intriguing case of human diversity. These hominins had a mixture of primitive and modern features, suggesting they might have been a transitional form between earlier and later human species. The fact that Homo naledi potentially lived alongside early modern humans further complicates our understanding of human evolution and diversity. These findings challenge our previous notions of human evolution and suggest that our ancient world was home to a much wider array of human-like species than we initially thought. This greater diversity in our evolutionary past highlights the complexity of human origins and the many paths that evolution took in shaping our lineage. Archaeological discoveries have revealed surprising evidence of advanced medical procedures in ancient skeletal remains. One of the most remarkable findings is trepanation, a surgical technique involving the drilling of holes in the skull. This practice dates back at least 7,000 years and has been found in remains across multiple continents, suggesting it was a widespread and accepted medical procedure. Examinations of these ancient skulls show signs of healing around the surgical sites, indicating that many patients survived the operation. This survival rate is a testament to the skill of ancient surgeons and their understanding of anatomy. Some skulls even show multiple healed trepanations, suggesting that the procedure was performed more than once on the same individual. Beyond trepanation, evidence of other sophisticated medical practices has been uncovered. Ancient Egyptian mummies have revealed complex dental work, including drilling of teeth to relieve abscesses and the use of gold wire to stabilize loose teeth. In Europe, remains dating back to the Roman era have shown signs of cataract surgery and the use of prosthetic limbs. Perhaps most astonishing is the discovery of what appears to be the world's oldest known prosthetic body part, a wooden toe found on an Egyptian mummy dating back 3,000 years. The level of craftsmanship and functionality of this prosthetic suggests a deep understanding of biomechanics and a highly developed approach to restoring mobility. These findings challenge our perceptions of ancient medical knowledge and highlight the ingenuity of our ancestors in addressing health issues. Recent archaeological discoveries have shaken our long-held beliefs about human migration patterns. In various parts of the world, ancient remains have been unearthed that don't fit neatly into the established timeline of human expansion across the globe. One striking example comes from North America, where fossilized footprints found in New Mexico have been dated to 23,000 years ago. This finding pushes back the timeline of human presence in the Americas by several thousand years, challenging the previously accepted theory that humans first arrived in the region around 13,000 years ago. Similarly, in Australia, stone tools discovered in the Majid-Bebe rock shelter suggest human habitation as far back as 65,000 years ago. This is significantly earlier than previous estimates, which placed the arrival of humans in Australia around 50,000 years ago. These findings have profound implications for our understanding of early human capabilities, particularly in terms of maritime travel and adaptation to new environments. In Europe, recent genetic studies of ancient remains have revealed a more complex picture of human migration and interbreeding. DNA analysis has shown evidence of multiple waves of migration, including previously unknown populations that contributed to the genetic makeup of modern Europeans. These discoveries highlight the intricate web of human movement and interaction that shaped our species' history, proving that our ancestors were far more mobile and adaptable than we once thought. Ancient human remains continue to puzzle scientists with their unexpected physical characteristics. One intriguing example is the elongated skulls found in various parts of the world, including Peru and Egypt. These skulls are significantly longer than typical human skulls, leading to debates about their origin and purpose. While some argue for intentional cranial deformation practices, others suggest potential genetic factors or even extraterrestrial influence. Another mysterious feature is the presence of red hair in mummies from diverse regions, including Egypt and China. This trait is particularly puzzling, given the rarity of red hair in these populations today. Scientists are still working to understand the genetic and environmental factors that might explain this phenomenon. Unusually large or small stature in some ancient remains also raises questions. The discovery of so-called giant skeletons, measuring well above average human height, has sparked theories about a race of giants in prehistory. Conversely, the remains of extremely small individuals, such as those found on the Indonesian island of Flores, challenge our understanding of human evolution and adaptation. Dental anomalies in ancient skulls present yet another mystery. Some remains show patterns of wear or modifications that cannot be easily explained by diet or cultural practices known to us today. These findings prompt researchers to reconsider ancient dental habits and potential unknown uses of teeth in early human societies. Skeletal remains discovered in various parts of the world have provided tantalizing clues about potential unknown human species or subspecies. These finds often exhibit unique combinations of features that don't quite fit with our current understanding of human evolution. One notable example is the discovery of Homo floresiensis on the Indonesian island of Flores. These small-bodied hominins, nicknamed hobbits, had a mix of primitive and advanced traits that puzzled scientists. Their small brain size and short stature, combined with sophisticated tool use, suggested a previously unknown branch of human evolution. Similarly, the Denisovans, known primarily from DNA evidence and a few fossil fragments found in Siberia, represent another potential human subspecies. While we have limited physical evidence, genetic studies indicate they were distinct from both modern humans and Neanderthals, yet interbred with both groups. More recently, the discovery of Homo naledi in South Africa has further complicated our family tree. These hominins had a unique mosaic of features, combining a small brain with a body adapted for bipedalism and possibly even ritualistic behavior. Such finds continue to reshape our understanding of human evolution, suggesting a more complex and diverse ancestral lineage than previously thought. Dental patterns in ancient remains offer fascinating insights into the diets and lifestyles of our ancestors, sometimes revealing surprising and seemingly anachronistic details. One intriguing discovery comes from the analysis of Neanderthal teeth, which showed evidence of plant materials trapped in dental calculus. This finding challenged the long-held belief that Neanderthals were exclusively meat-eaters, suggesting instead that they had a more varied diet, including vegetables and grains. In ancient Egyptian remains, researchers have found remarkably low rates of tooth decay, despite the civilization's reputation for having a sweet tooth. This paradox was explained by the presence of antibacterial agents in their foods and the abrasive nature of their bread, which contained sand particles that wore down teeth but also cleaned them. Perhaps most surprisingly, studies of teeth from medieval England revealed levels of dental hygiene that rival modern standards. Many skeletons showed signs of rudimentary dental work, including tooth extractions and even primitive fillings. This suggests a level of dental care that seems out of place for the era, challenging our perceptions of medieval health practices. These dental clues from the past continue to reshape our understanding of ancient diets and lifestyles, proving that our ancestors were often more sophisticated in their habits and healthcare than we previously imagined. Ancient remains have repeatedly surprised archaeologists and historians, forcing us to reconsider our understanding of early human technological capabilities. One striking example comes from the field of dentistry. In 2017, researchers examining a 14,000-year-old human tooth from northern Italy discovered evidence of sophisticated dental work. This Paleolithic tooth showed signs of being carefully hollowed out and filled with bitumen, a naturally occurring tar-like substance. This discovery predates the next known evidence of dental filling by about 13,000 years. This finding suggests that Ice Age humans possessed far more advanced medical knowledge and skills than previously thought. The precision required to perform such a procedure indicates a deep understanding of tooth anatomy and the use of specialized tools. It challenges our assumptions about the sophistication of Paleolithic societies and their ability to address complex health issues. Similar revelations have emerged in other fields. In Serbia, researchers found a bone fragment dated to nearly 45,000 years ago with precisely carved notches. This artifact is now considered one of the earliest examples of human decorative art and symbolic behavior. Its existence pushes back the timeline for the development of abstract thinking and artistic expression. These discoveries underscore the importance of remaining open to new evidence that may reshape our understanding of human history. They remind us that our ancestors were likely far more ingenious and capable than we often give them credit for, and that the roots of modern technology and medicine may stretch much further into the past than we once believed. Several ancient maps have puzzled historians and cartographers due to their unexpectedly accurate depictions of geographical features that were supposedly unknown at the time of their creation. One of the most famous examples is the Piri Reis map, drawn in 1513 by Ottoman admiral and cartographer Piri Reis. This map shows parts of South America, Africa, and even Antarctica with surprising accuracy, despite being created decades before some of these areas were officially discovered by European explorers. Another intriguing example is the Boche map, created by Philippe Boche in 1739. This map appears to show an ice-free Antarctic coastline, which is particularly baffling as the continent was not officially discovered until 1820. The level of detail in the coastline has led some researchers to speculate about the possibility of ancient civilizations having advanced mapping capabilities. The Xenomap, allegedly created in the late 14th century, depicts Nordic lands, including Greenland, with remarkable precision. What makes this map controversial is its purported creation date, which predates official European exploration of these regions. The accuracy of the coastlines and the inclusion of islands that were not widely known at the time have fueled debates about its authenticity and origin. These maps challenge our understanding of ancient geographical knowledge and exploration. While some researchers argue that they provide evidence of advanced ancient civilizations or pre-Columbian transoceanic contact, others suggest that they may be the result of compilation from various sources, including oral traditions and now lost earlier maps. Regardless of their true origins, these ancient maps continue to intrigue scholars and enthusiasts alike, prompting us to question the limits of early human exploration and cartographic abilities. Ancient maps have long fascinated historians and cartographers, offering tantalizing glimpses of geographical knowledge that seems to predate official discoveries. Some of these maps depict landmasses with uncanny accuracy, raising questions about how their creators obtained such information. One notable example is the Piri Reis map, created in 1513 by Ottoman admiral and cartographer Piri Reis. This map shows parts of South America, Africa, and even Antarctica with surprising detail. What makes this particularly intriguing is that Antarctica was not officially discovered until 1820. Some researchers argue that the map's depiction of Antarctica's coastline matches the subglacial topography, which has only been revealed through modern seismic surveys. Another puzzling case is the Wald-Siemler map from 1507, which shows a complete outline of South America and labels it as America, more than a decade before Magellan's expedition circumnavigated the globe. This map raises questions about the extent of undocumented explorations and the exchange of geographical information during that era. These ancient maps challenge our understanding of historical exploration and suggest that knowledge of distant lands may have been more widespread than previously thought. They invite us to reconsider the conventional narratives of discovery and to explore the possibility of earlier, undocumented voyages that expanded human understanding of our planet's geography. Ancient civilizations developed remarkable navigation techniques for long-distance travel, relying on a combination of celestial observations and environmental cues. One of the most widely used methods was celestial navigation, where travelers used the positions of stars, the sun, and other celestial bodies to determine their location and direction. The North Star, also known as Polaris, was particularly crucial for navigation in the northern hemisphere, as its position remains relatively fixed in the night sky. Many ancient seafaring cultures, such as the Polynesians, mastered the art of reading ocean swells and currents to navigate vast distances across open water. They observed the patterns of waves, the direction of prevailing winds, and the behavior of seabirds to maintain their course. These skilled navigators also used their knowledge of star paths and the positions of celestial bodies at different times of the year to estimate their latitude and longitude. On land, ancient travelers often relied on natural landmarks, such as mountain ranges, rivers, and distinctive rock formations, to guide their journeys. They created detailed mental maps of their surroundings and passed this knowledge down through generations. Some civilizations, like the Incas, built extensive road networks with carefully placed markers and rest stations to facilitate long-distance travel and communication across their vast empire. As trade routes expanded and became more established, ancient civilizations began creating rudimentary maps and written itineraries. These early navigational aids, combined with oral traditions and the expertise of experienced guides, allowed merchants, explorers, and pilgrims to undertake increasingly ambitious journeys across continents and seas, laying the foundation for the global connections we enjoy today. Ancient maps offer surprising insights into the cartographic skills of our ancestors, often surpassing our expectations of early civilizations. These historical artifacts reveal a level of geographical knowledge and mapping techniques that were remarkably advanced for their time. One striking example is the Piri Reis map, created in 1513 by Ottoman admiral and cartographer Piri Reis. This map accurately depicts parts of South America, Africa, and even Antarctica, which was not officially discovered until 3 centuries later. The precision of coastlines and the inclusion of lands thought to be unknown at the time have led to much speculation about the sources of information available to ancient mapmakers. Similarly, the Tabula Rogeriana, a world map created by Arab geographer Muhammad al-Idrisi in 1154, shows an impressive understanding of global geography. It accurately represents the spherical nature of Earth and includes detailed information about regions as far apart as Scandinavia and Southeast Asia. This level of accuracy challenges our assumptions about the limits of medieval geographical knowledge. These ancient maps not only demonstrate advanced cartographic skills, but also suggest the existence of extensive trade networks and exploration that may have been more widespread than previously thought. They prompt us to reconsider our understanding of ancient seafaring capabilities and the extent of early global connections, pushing us to expand our view of early human achievements in navigation and world mapping. Ancient civilizations demonstrated remarkable knowledge of longitude and latitude, far beyond what many might expect. The Babylonians, as early as 2,000 years before the Common Era, divided the celestial sphere into 360 degrees. This system laid the groundwork for our modern geographic coordinate system. In ancient Greece, Eratosthenes not only calculated the circumference of the Earth with surprising accuracy, but also developed a system of parallels and meridians. He created a grid over a map of the known world, foreshadowing modern cartographic techniques. This achievement was particularly impressive, given the limited tools and knowledge of his time. The ancient Chinese also made significant contributions. During the Han Dynasty, they invented the south-pointing chariot, a mechanical device that always pointed south regardless of the direction of travel. While not directly related to longitude and latitude, this invention showcased their advanced understanding of directional navigation. Perhaps most intriguing is the Antikythera mechanism, discovered in a shipwreck off the coast of Greece. This ancient analog computer, dating back to around 100 BCE, could track the positions of celestial bodies and even predict solar eclipses. Its sophistication suggests that ancient Greek astronomers and mathematicians had a far more advanced understanding of celestial coordinates than previously thought, which directly relates to the principles underlying longitude and latitude. Ancient maps have long intrigued historians and cartographers, offering tantalizing clues about early human understanding of Earth's shape. Some of these maps, dating back centuries before the official recognition of Earth as a sphere, contain surprising accuracies that hint at a more advanced geographical knowledge than previously thought. One notable example is the Piri Reis map. Created in 1513 by Ottoman admiral and cartographer Piri Reis. This map accurately depicts the coastlines of South America and Africa with remarkable precision, considering the limited exploration of these regions at the time. What's particularly striking is the map's portrayal of Antarctica, a continent not officially discovered until much later. The coastline shown on the Piri Reis map bears a striking resemblance to the actual landmass hidden beneath the ice, suggesting access to information far beyond the scope of contemporary explorations. Another intriguing case is the Buache map of 1739, which shows a detailed rendition of Antarctica without its ice cover. This map predates the official discovery of Antarctica by nearly 80 years, raising questions about the sources of information available to its creator, Philippe Buache. The accuracy of the subglacial topography depicted on this map has led some researchers to speculate about the existence of ancient, advanced civilizations with sophisticated mapping capabilities. These maps, along with others from various cultures and time periods, challenge our understanding of ancient geographical knowledge. They suggest that some civilizations may have possessed a more accurate understanding of Earth's shape and layout than officially recognized, possibly passed down through generations or derived from now lost exploration records. While the exact origins and methods behind these maps remain a subject of debate, they continue to fuel discussions about the extent of ancient geographical understanding and the potential for lost knowledge in our distant past. Ancient seafaring cultures left behind intriguing artifacts that hint at advanced navigation techniques far beyond what we once believed possible for their time. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, stands out as a marvel of ancient engineering. This complex bronze device, dating back over 2,000 years, could track celestial movements with astonishing accuracy, suggesting a deep understanding of astronomy and its application to navigation. In the Pacific, the Marshall Islands stick charts represent another form of sophisticated navigation tool. These intricate arrangements of shells and fibers mapped ocean swells and currents, allowing Polynesian sailors to navigate vast stretches of open water with remarkable precision. These charts demonstrate a profound grasp of oceanography that modern science is still working to fully comprehend. The Vikings, renowned for their seafaring prowess, may have used sunstones to determine the position of the sun on cloudy days. These crystals of Iceland's spar could polarize light, potentially allowing sailors to navigate even when the sun was obscured. This ingenious use of natural materials showcases the creativity and resourcefulness of ancient navigators. These artifacts challenge our perceptions of ancient technological capabilities. They suggest that our ancestors possessed knowledge and tools that were lost over time, possibly due to changing cultures, natural disasters, or the simple passage of years. As we continue to uncover and study these remnants of the past, we gain new insights into the ingenuity of ancient civilizations and the sophisticated methods they used to explore and understand their world. Ancient trade routes uncovered through historical maps are reshaping our understanding of prehistoric global connections. These cartographic revelations show that our ancestors were far more interconnected than previously thought, with complex networks spanning vast distances across land and sea. Recent discoveries have unveiled trade routes linking distant civilizations as far back as 5,000 years ago. For instance, maps detailing maritime routes between the Indus Valley and Mesopotamia suggest that these ancient cultures engaged in regular commerce, exchanging goods, ideas, and technologies. This challenges the notion that early civilizations developed in isolation, instead pointing to a world where knowledge and innovation spread rapidly across continents. Intriguingly, these ancient maps also highlight the impressive navigational skills of our forebears. They indicate that prehistoric sailors possessed sophisticated knowledge of ocean currents, prevailing winds, and celestial navigation, allowing them to undertake long sea voyages with remarkable accuracy. This expertise enabled the establishment of trade networks that would have seemed impossible given the technological limitations of the time. Furthermore, the discovery of land-based trade routes, such as early iterations of the Silk Road, demonstrates that even inland civilizations were part of this global exchange. These findings force us to reconsider the pace of cultural and technological diffusion in the ancient world, suggesting a much more dynamic and interconnected prehistoric era than previously imagined. Ancient maps offer a fascinating glimpse into how our planet has changed over centuries and millennia. These historical documents reveal shifts in coastlines, the disappearance of lakes and rivers, and alterations in vegetation patterns, all of which provide valuable insights into long-term climate trends and geographical transformations. One striking example is the gradual desiccation of the Sahara region. Maps from ancient Egypt and Greece show a much greener North Africa, with numerous rivers and lakes that have since vanished. This dramatic change reflects a significant shift in climate patterns over the past 5,000 years, transforming a once lush landscape into the vast desert we know today. Coastal changes are also evident in ancient cartography. Maps from the Roman era show the coastline of the Netherlands extending much further than it does now, indicating substantial land loss due to rising sea levels and erosion. Conversely, maps of the Nile Delta reveal how sediment deposition has extended the coastline seaward over time, demonstrating the dynamic nature of our planet's geography. Ancient maps also document the disappearance of entire bodies of water. The Aral Sea, once one of the largest lakes in the world, appears prominently on maps from the 19th century. However, more recent maps show its dramatic shrinkage due to human intervention and climate change, providing a stark illustration of how quickly significant geographical features can be altered. Ancient maps have long fascinated historians and archaeologists, but recent comparisons with modern satellite imagery have revealed surprising accuracies in some of these old charts. Certain maps from centuries ago show geographical features that were unknown or hidden at the time, yet align remarkably well with what we can now see from space. One striking example is the Piri-Reis map, created in 1513 by an Ottoman admiral. This map shows parts of the Antarctic coastline with surprising precision, despite the continent not being officially discovered until much later. When overlaid with modern satellite images, some sections of the coastline match up almost perfectly, including features that were hidden under ice at the time and have only recently been revealed due to climate change. Similarly, ancient Chinese maps have been found to accurately depict islands and coastlines in the South China Sea that were submerged during the time the maps were made. These underwater features, now visible through satellite technology, match the locations and shapes shown on maps created thousands of years ago. This raises intriguing questions about the mapmaker's sources of information and the possibility of ancient sea level changes. These alignments between ancient maps and modern imagery challenge our understanding of early navigation and geographical knowledge. They suggest that some ancient civilizations may have had more advanced surveying techniques or access to older, now lost sources of information than previously thought. As satellite technology continues to improve, more hidden geographical features may be discovered, potentially shedding new light on the accuracy and origins of other ancient maps. Throughout history, humans have built incredible structures that continue to baffle us today. The Great Pyramid of Giza stands as one of the most enduring enigmas. Constructed around 4,500 years ago, this massive monument has perplexed archaeologists and engineers alike. How ancient Egyptians transported and precisely placed 2 million stone blocks, some weighing up to 80 tons, remains a subject of debate and speculation. Halfway across the world, the intricate stone cities of the Inca, such as Machu Picchu, pose their own questions. Built high in the Andes Mountains without the use of mortar, these structures feature stones cut and fitted so precisely that not even a knife blade can slip between them. The technological sophistication required for such construction seems at odds with the tools available to the Inca at that time. In modern-day Turkey, the site of Göbekli Tepe presents an even older mystery. Predating Stonehenge by 6,000 years, this complex of circular structures was built by hunter-gatherers, challenging our understanding of prehistoric societies. The site's massive T-shaped pillars, some weighing up to 16 tons, bear intricate carvings of animals and abstract symbols. How these pillars were quarried, transported, and erected by a nomadic people without advanced tools or even pottery remains unexplained. These ancient wonders not only showcase the ingenuity of our ancestors, but also highlight how much knowledge has been lost to time. As we continue to study these structures, we may yet uncover the secrets of their construction, shedding new light on the capabilities of ancient civilizations. Ancient civilizations possessed remarkable knowledge of acoustics, as evidenced by several impressive structures that still stand today. The Great Ball Court at Chichen Itza in Mexico is a prime example of sophisticated acoustic engineering. This massive open-air court, stretching nearly the length of an American football field, exhibits an extraordinary phenomenon. A person standing at one end can clearly hear a whisper from someone at the opposite end, over 500 feet away. The Greeks and Romans also mastered acoustic design in their amphitheaters. The theatre of Epidaurus in Greece, built in the 4th century BCE, is renowned for its exceptional sound quality. Even today, a whisper on stage can be heard clearly in the back row, nearly 200 feet away. This acoustic marvel is achieved through the precise geometry of the seating area and the sound-reflecting properties of the limestone seats. In India, the Golconda Fort near Hyderabad features an acoustic feat known as the clapping portico. A single clap at a specific spot under the main dome can be heard at the hilltop pavilion over half a mile away. This served as an ingenious warning system against intruders. These acoustic wonders were not accidents, but the result of careful design and deep understanding of sound behavior. The sophisticated acoustic properties of these ancient structures challenge our perceptions of past technological capabilities. They demonstrate that our ancestors possessed advanced knowledge of physics and engineering, often achieving results that modern architects still strive to replicate. These acoustic marvels continue to intrigue scientists and visitors alike, serving as enduring testaments to the ingenuity of ancient civilizations. Ancient civilizations across the globe have left us with remarkable structures that demonstrate an astonishing level of astronomical knowledge. The Great Pyramid of Giza in Egypt stands as a testament to precise engineering and celestial understanding. Its sides align almost perfectly with the cardinal directions, and its shafts point to specific stars that were significant in ancient Egyptian beliefs. Halfway across the world, Stonehenge in England continues to captivate researchers with its astronomical alignments. The monument's layout corresponds to the movements of the sun, particularly during solstices. The precision required to create these alignments suggests a deep understanding of celestial cycles that seems far beyond what we typically associate with Neolithic cultures. In Central America, the Mayan city of Chichen Itza showcases the El Castillo Pyramid, also known as the Temple of Kukulkan. This structure is a physical representation of the Mayan calendar, with features that mark equinoxes and other important astronomical events. During the spring and autumn equinoxes, the play of light and shadow creates the illusion of a serpent descending the pyramid's steps. demonstrating a sophisticated blend of architecture and astronomical knowledge. These ancient structures challenge our perceptions of early human capabilities. They raise questions about the transfer of knowledge across ancient civilizations and prompt us to reconsider the depth of astronomical understanding possessed by our ancestors. The precision and complexity of these alignments continue to astound modern scientists and engineers, hinting at a level of expertise that seems almost impossible for their time. Ancient constructions from prehistoric times continue to astound archaeologists and engineers alike, pushing the boundaries of our understanding of early human capabilities. The precision and scale of these structures, built thousands of years ago, often seem to defy the technological limitations we assumed existed in those eras. Take, for example, the Great Pyramid of Giza in Egypt. Built around 4,500 years ago, this massive structure stands at a height of over 450 feet and was constructed using an estimated 2.3 million stone blocks. The level of accuracy in its construction is remarkable, with the base almost perfectly level and the sides aligned to the cardinal directions with astonishing precision. This feat becomes even more impressive when we consider that the ancient Egyptians achieved this without modern surveying equipment or advanced mathematics. Similarly, the megalithic structures of Stonehenge in England present their own engineering marvels. The transportation and erection of massive stone blocks, some weighing up to 40 tons, over distances of hundreds of miles, was accomplished without the benefit of the wheel or metal tools. The sophisticated astronomical alignments of the stones also suggest a level of scientific knowledge that was previously thought beyond the reach of Neolithic peoples. In South America, the ancient city of Machu Picchu showcases incredible feats of civil engineering. Built on a mountain ridge, the city features complex water management systems, earthquake-resistant foundations, and precisely cut stone blocks that fit together without mortar. The transportation of these massive stones up steep mountain slopes and their subsequent precise placement continues to puzzle modern engineers. These examples challenge our preconceptions about prehistoric technological capabilities and force us to reconsider the ingenuity and resourcefulness of our ancient ancestors. Ancient civilizations have left us with remarkable structures that continue to baffle modern scientists, particularly when it comes to their thermal properties. One striking example is the Great Pyramid of Giza in Egypt. Despite the scorching desert heat outside, the interior of the pyramid maintains a constant temperature of around 20 degrees Celsius. This natural climate control system has puzzled researchers for centuries, as the ancient Egyptians had no access to modern cooling technologies. Another intriguing case is the Hypogeum of Hal Saflieni in Malta, a subterranean structure dating back to around 3600 BCE. This underground complex consists of halls, chambers, and passages carved out of solid limestone. Remarkably, it maintains a constant temperature of about 16 degrees Celsius throughout the year, regardless of the external weather conditions. The precise mechanism behind this thermal regulation remains a mystery to this day. In South America, the ancient Incan city of Ollantaytambo in Peru showcases impressive thermal engineering. The city's stone structures, particularly the agricultural terraces, demonstrate an uncanny ability to absorb heat during the day and release it slowly at night. This creates a microclimate that protects crops from frost and extreme temperature fluctuations, a feat achieved without modern materials or technology. These examples highlight the ingenuity of ancient builders and their deep understanding of natural thermal properties. While we continue to study these structures, their full secrets remain elusive, reminding us that there is still much to learn from the wisdom of our ancestors. Ancient structures around the world offer intriguing clues about our ancestors' understanding of Earth's magnetic field. Some archaeological sites, particularly in Europe and Mesoamerica, show alignment patterns that correlate with historical magnetic field orientations. These alignments suggest that ancient builders might have possessed sophisticated knowledge of geomagnetic properties, possibly using this information for navigation, agriculture, or spiritual purposes. One notable example is the placement of certain Mesoamerican pyramids. Researchers have found that some of these structures are oriented in ways that correspond to the magnetic north at the time of their construction. This alignment differs from true geographic north, indicating that the builders likely used magnetic compasses or other methods to detect the Earth's magnetic field. Similarly, studies of ancient European megalithic structures have revealed potential correlations with historical magnetic field directions. Some stone circles and other Neolithic monuments show orientations that align with the magnetic field as it existed thousands of years ago. This suggests that these early societies might have had methods to detect and utilize geomagnetic information in their construction practices. While the exact methods these ancient cultures used to detect magnetic fields remain a mystery, these architectural alignments provide compelling evidence of early human awareness of Earth's magnetic properties. This knowledge challenges our understanding of ancient technological capabilities and offers a fascinating glimpse into the sophisticated observations and practices of our ancestors. Several ancient structures showcase remarkable earthquake-resistant designs that have withstood the test of time. The Incan city of Machu Picchu in Peru is a prime example. Built in the 15th century, its stone buildings feature precisely cut blocks that fit together without mortar. This technique, known as ashlar masonry, allows the structures to shift slightly during seismic activity and then settle back into place, preventing collapse. In Greece, the Parthenon on the Acropolis of Athens has endured numerous earthquakes since its construction in the 5th century BCE. Its durability is partly due to the flexibility of its column and beam structure, which can absorb and dissipate seismic energy. The ancient Greeks also used a technique called anathyrosis, where only the edges of stone blocks were cut to fit tightly, leaving the center slightly recessed. This method improved the stability of the structure during ground movements. The Qutb Minar in Delhi, India, built in the early 13th century, is another example of earthquake-resistant architecture. This 73-meter-tall minaret has withstood several major earthquakes, thanks to its tapered design and the use of flexible materials like iron clamps and beams within the structure. These ancient buildings demonstrate that our ancestors possessed sophisticated engineering knowledge, enabling them to create structures that could withstand the powerful forces of nature. Their innovative techniques continue to inspire modern architects and engineers in designing resilient structures for earthquake-prone regions. Ancient civilizations left behind remarkable structures that demonstrate sophisticated mathematical understanding. The Great Pyramid of Giza, built over 4,500 years ago, exhibits precise geometric proportions and alignment with cardinal directions. Its builders incorporated the mathematical concept of pi into its design, centuries before it was formally defined. Stonehenge in England, constructed around 5,000 years ago, reveals intricate astronomical alignments. Its layout suggests knowledge of complex celestial cycles, including the ability to predict solar and lunar eclipses. The positioning of the stones required advanced calculations to achieve such precise astronomical observations. The Nazca lines in Peru, created between 500 BCE and 500 CE, feature enormous geoglyphs visible only from the air. These designs maintain their proportions over vast distances, indicating a grasp of geometry and large-scale plotting techniques. Some patterns align with astronomical events, hinting at a deep understanding of celestial movements. These monuments showcase how early humans applied mathematical concepts to architecture and astronomy. Their enduring precision continues to astonish modern researchers, providing tangible evidence of the advanced knowledge possessed by our ancestors long before the development of formal mathematical systems. Throughout history, ancient civilizations have constructed remarkable structures that continue to baffle modern engineers and archaeologists. The Great Pyramid of Giza in Egypt stands as a testament to the ingenuity of ancient builders. Constructed around 4,500 years ago, this massive monument consists of over 2 million stone blocks, each weighing several tons. The precision with which these blocks were cut and fitted together, as well as the advanced understanding of mathematics and astronomy required for its construction, surpasses what many believe possible for that era. Another enigmatic structure is Stonehenge in England. built between 3000 and 2000 BCE. The transportation and arrangement of its massive stone pillars, some weighing up to 40 tons, pose significant challenges even with modern technology. The method used to move these enormous stones over long distances and position them with such precision remains a subject of debate among experts. In South America, the ancient city of Machu Picchu showcases the Inca civilization's mastery of stone construction. Built in the 15th century, its walls feature massive stone blocks fitted so tightly together that not even a knife blade can be inserted between them. This technique, known as ashlar masonry, has allowed the structures to withstand centuries of earthquakes and weathering. The Moai statues of Easter Island are another example of seemingly impossible ancient engineering. These colossal stone figures, averaging 13 feet in height and weighing up to 75 tons, were somehow transported across the island and erected without the use of wheels or large animals. The methods used by the Rapa Nui people to move and place these massive statues continue to puzzle researchers today. Ancient civilizations often displayed remarkable sophistication in urban planning and design, as evidenced by several archaeological sites around the world. One striking example is the city of Mohenjo-Daro in modern-day Pakistan, built around 4,500 years ago. This Indus Valley city featured a grid-like street system, advanced drainage networks, and multi-story buildings, showcasing a level of urban organization far ahead of its time. In South America, the Incan city of Machu Picchu demonstrates ingenious design principles. Built high in the Andes Mountains, the city's layout maximizes natural sunlight and manages water flow through a complex system of channels and fountains. The precision of stone cutting and fitting in Machu Picchu's structures also highlights the advanced engineering skills of its builders. The ancient Egyptian city of Alexandria, founded by Alexander the Great, was meticulously planned with wide, straight streets arranged in a grid pattern. This design facilitated efficient movement and improved ventilation throughout the city. Alexandria also boasted advanced infrastructure, including a complex water supply system and the famous Lighthouse of Alexandria, one of the 7 wonders of the ancient world. These ancient sites reveal that our ancestors possessed a deep understanding of urban planning principles, including efficient use of space, resource management, and harmonious integration with the natural environment. Their achievements continue to inspire and inform modern urban planners and architects, reminding us that innovative city design has been a hallmark of human civilization for millennia. Several ancient texts contain descriptions of technologies or knowledge that seem remarkably advanced for their era. The Vedas, ancient Hindu scriptures dating back thousands of years, include references to flying machines called vimanas and weapons resembling modern missiles and atomic bombs. While these accounts are likely metaphorical, they demonstrate sophisticated imagination and conceptual thinking. The Greek Antikythera mechanism, described in texts from the 2nd century BCE, was an intricate mechanical device used to predict astronomical positions and eclipses. Its complexity was not matched for over 1,000 years, showcasing ancient Greek understanding of celestial mechanics and precision engineering. Egyptian hieroglyphs depict what some interpret as electric lighting in the form of elongated bulbs. Though controversial, these images have sparked debate about the possible existence of advanced technology in ancient Egypt. Similarly, Baghdad batteries, clay pots containing copper and iron rods, suggest rudimentary understanding of electrochemistry in Mesopotamia 2,000 years ago. Lastly, the Maya civilization left codices detailing precise astronomical calculations and complex calendar systems, indicating a level of mathematical and observational prowess that rivaled contemporary cultures worldwide. These ancient texts remind us that human ingenuity and scientific curiosity have deep historical roots, often surpassing our modern expectations of past capabilities. Undeciphered scripts present a fascinating puzzle for linguists and historians, offering tantalizing glimpses into ancient cultures while simultaneously challenging our assumptions about communication. These mysterious writing systems, found on artifacts, monuments, and documents across the world, represent entire bodies of knowledge that remain locked away from modern understanding. One of the most intriguing aspects of undeciphered scripts is how they force us to confront the limits of our linguistic knowledge. While we have successfully decoded many ancient writing systems, such as Egyptian hieroglyphs and Mesopotamian cuneiform, others continue to resist our best efforts at translation. This resistance suggests that some ancient cultures may have developed unique ways of encoding information that diverge significantly from the patterns we recognize in known languages. The existence of these unreadable texts also raises questions about the diversity of human communication throughout history. Each undeciphered script potentially represents a distinct way of perceiving and recording the world, shaped by the unique cultural, environmental, and historical factors of its creators. By studying these scripts, even without fully understanding them, researchers can gain insights into the cognitive processes and cultural priorities of ancient societies. Moreover, undeciphered scripts challenge our notions of historical continuity and cultural transmission. They remind us that vast stores of human knowledge and experience have been lost over time, creating gaps in our understanding of the past. As we continue to develop new technologies and techniques for analyzing these ancient texts, we may yet unlock secrets that could reshape our understanding of human history and communication. Ancient languages often surprise us with their sophistication and complexity. Sumerian, one of the earliest known written languages, had an intricate system of cuneiform writing that could express complex ideas and record detailed historical events. Despite being over 5,000 years old, Sumerian texts reveal a rich vocabulary and grammatical structures that rival modern languages. Sanskrit, the classical language of India, is renowned for its elaborate system of compound words and precise grammatical rules. Its complexity allows for nuanced expression and has been the subject of extensive linguistic study. The language's ability to convey philosophical and scientific concepts with great accuracy has led some scholars to compare its logical structure to that of computer programming languages. The ancient Egyptian hieroglyphic system is another example of unexpected complexity. Far from being merely pictorial, hieroglyphs combined logographic, syllabic, and alphabetic elements to create a versatile writing system. This allowed scribes to record everything from religious texts to mathematical calculations with remarkable precision. Classical Chinese, used in ancient texts, demonstrates complexity through its concise nature. Each character can represent a word or concept, allowing for dense, meaning-packed sentences. This efficiency in communication required readers to have a deep understanding of context and cultural references, making it a highly sophisticated system of written expression. Ancient writings from various cultures contain intriguing references to scientific concepts that were not fully understood or rediscovered until centuries later. The Vedic texts of ancient India, for instance, describe atomic theory and the concept of multiple universes, ideas that only gained scientific traction in the 20th century. These texts speak of infinitesimal particles as the building blocks of matter, echoing modern atomic theory. In ancient Greece, the philosopher Democritus proposed the existence of atoms, indivisible particles that make up all matter. This concept lay dormant for nearly 2,000 years before being revived and proven by modern science. Similarly, the ancient Mayans demonstrated a sophisticated understanding of astronomy, accurately predicting celestial events and creating a calendar system that rivals the precision of our modern calendars. Chinese texts from over 2,000 years ago describe the circulation of blood in the body, a concept not fully understood in Western medicine until the 17th century. These ancient writings also contain references to magnetism and the use of lodestones for navigation, technologies that would not be widely adopted in other parts of the world for centuries. The Egyptian Ebers papyrus, dating back to 1550 BCE, contains descriptions of the heart as the center of blood supply and mentions blood vessels, concepts that align with modern cardiovascular understanding. These examples suggest that ancient civilizations possessed knowledge that was lost or overlooked, only to be rediscovered by modern science, raising questions about the cyclical nature of human knowledge and the potential for ancient wisdom to inform current scientific inquiry. Ancient texts have long fascinated historians and archaeologists, often providing tantalizing clues about past civilizations. In recent years, archaeological discoveries have corroborated several accounts found in these age-old writings. The Bible, one of the most widely studied ancient texts, has yielded numerous archaeological confirmations. The ancient city of Jericho, described in the book of Joshua, was long thought to be mythical until excavations revealed its ruins, complete with collapsed walls that align with the biblical narrative. Similarly, the existence of the Hittite civilization, mentioned frequently in the Old Testament, was confirmed by archaeological finds in Turkey during the 20th century. In another part of the world, ancient Chinese texts like the Shiji or records of the Grand Historian have proven remarkably accurate. This text described the terracotta army of the first emperor of China centuries before its discovery in 1974. The level of detail in the text, including the number and arrangement of the warriors, closely matched the archaeological findings. Greek historian Herodotus wrote about many places and events that were once dismissed as fanciful, but have since been verified. His description of the ancient Egyptian labyrinth, long thought to be exaggerated, was confirmed when the ruins of a massive complex were discovered at Hawara. These discoveries not only validate historical texts, but also provide valuable insights into ancient cultures and their perceptions of the world around them. Ancient writings from various cultures have revealed surprising insights that challenge our conventional understanding of human intellectual progress. Texts from Mesopotamia, Egypt, and India contain advanced mathematical concepts and astronomical observations that were once thought to have originated much later in history. For instance, Babylonian clay tablets from around 1800 BCE show evidence of complex mathematical calculations, including the use of what we now call the Pythagorean theorem, long before Pythagoras was born. In ancient India, the Vedic texts dating back to at least 1500 BCE contain sophisticated ideas about the nature of consciousness and reality that parallel modern quantum physics concepts. These writings suggest a deep understanding of the interconnectedness of all things and the illusory nature of physical reality, ideas that Western science has only recently begun to explore. Chinese texts from the Zhou dynasty around 1046 BCE to 256 BCE describe a model of the universe that bears striking similarities to modern cosmological theories. They conceived of multiple worlds and dimensions, challenging the notion that such ideas are purely modern inventions. These ancient writings force us to reconsider the linear progression of human knowledge and suggest that advanced thinking about the universe and our place in it may have occurred in cycles throughout history, with insights being gained, lost, and rediscovered over time. This perspective encourages us to approach ancient wisdom with renewed respect and curiosity, recognizing that our ancestors may have possessed profound knowledge that we are only now beginning to rediscover and understand. Ancient texts that accurately describe distant lands offer fascinating glimpses into early human knowledge and exploration. The Norse sagas, written in medieval Iceland, provide surprisingly accurate descriptions of North America centuries before Columbus's voyage. These accounts, particularly the saga of Eric the Red, describe the coastlines, flora, and fauna of what is now Newfoundland and Labrador with remarkable precision. Another intriguing example comes from ancient Greek literature. Plato's dialogues mention a land called Atlantis, which some scholars believe may have been based on real geographical knowledge of the Americas or other distant lands. While the existence of Atlantis remains debated, the description of a large island continent beyond the Pillars of Hercules suggests awareness of lands across the Atlantic Ocean. Chinese historical records from as early as the 5th century describe a land called Fusang, located far to the east across the ocean. Some researchers argue that these accounts might refer to the western coast of North America, as they include details about native peoples and landscapes that align with what we now know about the region. The Periplus of the Erythraean Sea, a Greek merchant's guide from the 1st century, provides remarkably accurate descriptions of East African, Arabian, and Indian coastlines. It includes details about trade goods, local cultures, and geographical features that demonstrate extensive knowledge of these distant lands long before they were officially charted by European explorers. Ancient languages often reveal surprising links between cultures separated by vast distances, challenging our understanding of early human migrations and interactions. One intriguing example is the connection between Sanskrit, an ancient Indian language, and European languages like Greek and Latin. These languages share numerous similarities in vocabulary and grammar, suggesting a common ancestral language spoken thousands of years ago. Another unexpected linguistic connection appears between ancient Polynesian languages and some Native American languages. Certain words and grammatical structures show remarkable similarities, hinting at possible contact between these cultures long before European explorers reached the Americas. This connection raises fascinating questions about the seafaring capabilities of ancient Polynesians and their potential voyages across the Pacific Ocean. The ancient Sumerian language of Mesopotamia also displays unexpected links to languages from different parts of the world. Some linguists have noted similarities between Sumerian and languages from the Caucasus region, thousands of kilometers away. These connections suggest complex patterns of cultural exchange and migration in the ancient world that we are only beginning to unravel. These linguistic connections provide valuable clues about human history, trade routes, and cultural exchanges that occurred long before written records. By studying these unexpected language links, researchers continue to piece together the intricate tapestry of ancient human civilization, revealing a world far more interconnected than previously imagined. Ancient religious texts offer intriguing glimpses into the scientific understanding of prehistoric civilizations. While these texts were not primarily intended as scientific documents, they often contain observations and explanations of natural phenomena that reflect the knowledge and beliefs of their time. Many ancient texts describe celestial events and astronomical observations with surprising accuracy. For example, Babylonian clay tablets record detailed observations of planetary movements and eclipse predictions, showcasing a sophisticated understanding of celestial mechanics. Similarly, ancient Hindu texts contain remarkably precise calculations of the Earth's age and the concept of cosmic cycles, which align surprisingly well with modern scientific estimates. Some religious texts also provide insights into early medical knowledge. The Egyptian Ebers papyrus, while intertwining medical practices with religious beliefs, describes various ailments and treatments that demonstrate a basic understanding of human anatomy and herbal remedies. In the Bible, there are passages that suggest an awareness of quarantine procedures for managing infectious diseases, hinting at a rudimentary grasp of contagion. However, it is crucial to interpret these texts within their historical and cultural context. While they sometimes contain accurate observations, they also include mythological explanations and supernatural elements that do not align with modern scientific understanding. These texts reveal a complex interplay between empirical observation, cultural beliefs, and attempts to explain the natural world, providing a fascinating window into the development of human scientific thought. Ancient writings from various cultures around the world contain intriguing references to advanced civilizations that may have existed in the distant past. These accounts often describe societies with remarkable technological and scientific knowledge far beyond what we typically associate with ancient times. One of the most famous examples is the story of Atlantis, first mentioned by the Greek philosopher Plato. He described a highly advanced island nation with impressive architecture, advanced naval capabilities, and a complex social structure. While many scholars consider Atlantis to be a myth, the detailed nature of Plato's account has led some researchers to speculate about its potential basis in reality. Similarly, ancient Indian texts known as the Vedas contain descriptions of flying machines called vimanas, which some interpret as evidence of advanced aeronautical knowledge in prehistory. These texts provide detailed information about the construction and operation of these alleged craft, sparking debate about their true nature and origin. In South America, Legends of the Inca people speak of a time before their own civilization, when a highly advanced culture possessed incredible knowledge of astronomy, mathematics, and engineering. Some researchers point to the precise stonework and complex architectural designs found at sites like Puma Punku in Bolivia as potential evidence supporting these claims. Ancient civilizations faced numerous climate challenges throughout history, forcing them to develop innovative strategies for survival. The Indus Valley Civilization, which flourished around 5,000 years ago, experienced a significant shift towards aridity. As rainfall patterns changed, they responded by creating sophisticated irrigation systems and building dams to manage water resources more effectively. In Mesoamerica, the Maya civilization encountered severe droughts around 1,000 years ago. They adapted by constructing extensive reservoir systems and implementing water conservation techniques. These measures allowed them to sustain their population and agriculture in the face of diminishing rainfall. The ancient Egyptians provide another compelling example of adaptation. They relied heavily on the annual flooding of the Nile River for agriculture. When flood patterns became erratic due to climate fluctuations, they developed a complex system of canals and levees to control water distribution. This ingenuity enabled them to maintain agricultural productivity despite environmental challenges. In Northern Europe, the Vikings demonstrated remarkable adaptability during the medieval warm period. As temperatures rose, they expanded their settlements into Greenland and even North America. However, when the climate cooled again during the Little Ice Age, they adjusted their farming practices and relied more on fishing and hunting to survive in their harsh environment. Several ancient civilizations demonstrated remarkable abilities to predict and adapt to climate patterns, suggesting they possessed sophisticated climate prediction capabilities. The Maya of Central America, for instance, developed a complex calendar system that not only tracked celestial movements, but also correlated with long-term climate cycles. Archaeological evidence indicates they used this knowledge to plan agricultural activities and prepare for droughts. In South America, the Inca built vast networks of stone structures called sequays, which aligned with astronomical events and likely served as a system for tracking seasonal changes and predicting weather patterns. This allowed them to optimize their agricultural practices in the challenging environment of the Andes Mountains. The ancient Egyptians relied heavily on the annual flooding of the Nile River for agriculture. They developed methods to predict these floods by observing the heliacal rising of Sirius, the brightest star in the night sky. This enabled them to prepare for the inundation and maximize crop yields, demonstrating a sophisticated understanding of the relationship between celestial events and climate patterns. In China, detailed records of sunspot observations date back over 2,000 years. These observations, combined with other astronomical and meteorological data, allowed ancient Chinese astronomers to identify climate patterns and make predictions about future weather conditions. This knowledge was crucial for agricultural planning and imperial decision-making, highlighting the advanced nature of their climate prediction capabilities. Ancient climate records are reshaping our understanding of human technological development in surprising ways. By analyzing ice cores, tree rings, and sediment layers, scientists have uncovered detailed information about past climate conditions stretching back hundreds of thousands of years. These records reveal that our ancestors faced rapid and extreme climate shifts, often within a single human lifetime. One key finding is that periods of intense climate change often coincided with significant leaps in human innovation. For instance, during a particularly cold and dry period around 70,000 years ago, humans in Africa developed more sophisticated tools and began using symbols for communication. This challenges the idea that stable environments are necessary for technological progress. Moreover, climate records show that early agricultural societies had to contend with much more variable weather patterns than previously thought. This suggests that ancient farmers were more adaptable and innovative than we once believed, developing new crop varieties and irrigation techniques to cope with unpredictable conditions. These insights are prompting researchers to re-evaluate the relationship between environmental pressures and human ingenuity. Rather than seeing climate change as purely destructive, we now recognize it as a potential catalyst for technological advancement. This new perspective is not only changing our view of the past, but also informing how we might approach future climate challenges. Climate change has been a significant factor in the decline of several ancient civilizations. The Akkadian Empire in Mesopotamia, which flourished around 4,300 years ago, faced severe drought conditions that likely contributed to its downfall. Archaeological evidence suggests that a 200-year-long period of dry conditions and dust storms weakened agriculture and destabilized the empire. In the Americas, the classic Maya civilization experienced a series of intense droughts between 750 and 950 CE. These prolonged dry spells disrupted their sophisticated water management systems and agricultural practices, leading to food shortages, social unrest, and ultimately the abandonment of many major cities. The Indus Valley Civilization, one of the world's earliest urban cultures, also felt the impact of changing climate patterns. Around 4,000 years ago, shifts in monsoon patterns and river courses altered the agricultural landscape, contributing to the gradual decline of this advanced society. Even the mighty Roman Empire was not immune to the effects of climate change. A period known as the Roman climate optimum, characterized by warm, wet, and stable conditions, helped the empire thrive. However, as the climate became more volatile around 1,500 years ago, with colder temperatures and increased rainfall variability, it added stress to an already strained political and economic system, playing a role in the empire's eventual fall. Ancient civilizations often demonstrated remarkable knowledge of climate patterns through their architectural designs and urban planning. The Indus Valley Civilization, which flourished over 4,000 years ago, constructed intricate drainage systems and baths that helped manage seasonal monsoon rains. These structures reveal a sophisticated grasp of water management and climate cycles. In South America, the Incan city of Machu Picchu showcases an impressive understanding of rainfall patterns and erosion control. The city's builders designed a complex system of terraces and canals that efficiently distributed water during both wet and dry seasons, preventing landslides and maximizing agricultural productivity. The ancient Egyptians also displayed climate awareness in their monumental structures. The orientation of the Great Pyramid of Giza aligns precisely with the cardinal directions, suggesting an understanding of solar patterns. This alignment allowed the pyramid to cast no shadow on the equinoxes, demonstrating the builder's knowledge of seasonal changes. These examples highlight how ancient peoples observed and adapted to their environments, creating enduring structures that reflected their deep understanding of climate patterns. Their ingenuity continues to impress modern scientists and engineers, offering valuable insights into sustainable design and climate adaptation strategies. Ancient civilizations developed remarkable agricultural techniques to cope with shifting climate patterns. The Aztecs, for instance, created chinampas, artificial islands in shallow lakebeds. These floating gardens allowed them to expand farmland and adapt to fluctuating water levels caused by unpredictable rainfall. The fertile soil of chinampas, constantly replenished with nutrient-rich sediment, enabled year-round cultivation and high crop yields. In the arid regions of the Middle East, farmers perfected the qanat system, a network of underground tunnels that tapped into aquifers and transported water to fields. This ingenious method minimized water loss through evaporation, crucial in hot, dry climates. Qanats allowed communities to thrive in areas that would otherwise be too hostile for agriculture. The Inca civilization in South America developed an advanced system of terraced farming. By carving step-like platforms into steep mountain slopes, they created level surfaces for cultivation. This technique not only maximized land use in challenging terrain, but also helped manage water flow and prevent soil erosion. The Inca also utilized microclimates created by different altitudes to grow a diverse range of crops. In Southeast Asia, ancient farmers practiced an intricate form of rice paddy cultivation. They constructed elaborate systems of dikes, canals, and terraces to control water flow and maintain optimal growing conditions. This method allowed them to adapt to both drought and flood conditions, ensuring a stable food supply in a region prone to monsoons and varying rainfall patterns. Ancient climate proxies offer a fascinating window into the past, revealing hidden chapters of human history. Tree rings and ice cores, along with other natural records like lake sediments and coral reefs, act as time capsules, preserving evidence of environmental changes that occurred long before written records began. These proxies can uncover periods of intense human activity through subtle chemical and physical signatures. For instance, ice cores from Greenland have revealed spikes in lead concentrations coinciding with the rise and fall of ancient civilizations, reflecting increased metal production during times of economic prosperity. Similarly, tree rings can show periods of increased or decreased growth, which might indicate shifts in land use practices or agricultural intensification. In some cases, these proxies have even revealed previously unknown civilizations or cultural periods. For example, analysis of lake sediments in Central America has uncovered evidence of extensive Mayan land use and subsequent abandonment, helping archaeologists piece together the rise and fall of this ancient civilization. Pollen records preserved in these sediments can show when forests were cleared for agriculture and when they regrew, indicating periods of human settlement and abandonment. By combining data from multiple proxies, scientists can build a comprehensive picture of past climates and ecosystems, allowing them to infer how human societies interacted with their environments over time. This interdisciplinary approach, blending climatology, archaeology, and history, continues to shed new light on the complex relationship between human activity and environmental change throughout our species' long and often mysterious past. Throughout human history, societies have inadvertently altered their local climates through various practices, but deliberate attempts at large-scale climate modification are a relatively recent phenomenon. However, some ancient civilizations did engage in practices that could be considered early forms of geoengineering, albeit on a smaller scale. One intriguing example comes from the Amazon rainforest. Recent studies have revealed that pre-Columbian societies systematically altered the composition of the forest over vast areas. They cultivated and spread certain tree species that were useful for food and materials, effectively creating what scientists now call forest gardens. This large-scale forest management likely had some impact on local climate conditions, potentially increasing rainfall and carbon sequestration. In ancient China, there is evidence of attempts to modify local weather patterns. Historical records describe cloud seeding experiments conducted as early as 2,600 years ago. These involved burning specific substances to create smoke, which was believed to induce rainfall. While the effectiveness of these methods is questionable by modern standards, they represent early attempts to manipulate atmospheric conditions. Another example of ancient practices that could be considered proto-geoengineering comes from the Indus Valley civilization. Archaeological evidence suggests they developed sophisticated water management systems, including dams, reservoirs, and canals. These extensive hydrological works not only supported agriculture, but also likely influenced local microclimates by altering water distribution and vegetation patterns across large areas. Climate records from Earth's distant past reveal fascinating connections to human technological progress. Ice cores, tree rings, and sediment layers provide a detailed history of our planet's climate, stretching back hundreds of thousands of years. These records show that periods of climate stability often coincided with significant leaps in human innovation and technological development. During the Holocene epoch, which began approximately 11,600 years ago, Earth experienced a remarkably stable climate. This period of relative warmth and consistency allowed early agricultural societies to flourish, leading to the development of more complex civilizations. As humans settled into permanent communities, they had the opportunity to refine their tools, agricultural techniques, and early technologies. One striking example is the rapid advancement of Mesopotamian civilization during a period of favorable climate conditions around 5,000 years ago. The The stable environment allowed for the development of irrigation systems, leading to surplus food production. This surplus, in turn, supported population growth and specialization of labor, ultimately contributing to the invention of writing and the wheel. Conversely, periods of climate instability have sometimes spurred innovation out of necessity. The Little Ice Age, which occurred between the 16th and 19th centuries, led to advancements in heating technology and agriculture in Europe. These developments helped societies adapt to cooler temperatures and shorter growing seasons, showcasing how climate challenges can drive technological progress in unexpected ways. Prehistoric climate patterns offer intriguing insights into the potential for undiscovered ancient civilizations. These long-term environmental trends, recorded in ice cores, tree rings, and sediment layers, reveal periods of stability and upheaval that could have profoundly influenced human development. During times of favorable climate, with consistent rainfall and moderate temperatures, early societies may have flourished in regions now considered inhospitable. The African humid period, which lasted from about 14,000 to 5,000 years ago, transformed much of the Sahara into a lush, green landscape dotted with lakes. This dramatic shift in environment could have supported complex societies that have since vanished beneath the sands. Similarly, periods of rapid climate change might have spurred technological advancements or mass migrations, potentially giving rise to sophisticated cultures in unexpected locations. The end of the last ice age, approximately 11,000 years ago, led to rising sea levels that submerged vast areas of coastal land. Any civilizations that existed on these now underwater landscapes would be hidden from conventional archaeological methods. Recent discoveries, such as the ancient city of Nan Madol in Micronesia and the elaborate geoglyphs of the Amazon rainforest, demonstrate that advanced societies can develop in surprising places. As our understanding of prehistoric climate patterns grows, so too does the possibility of uncovering evidence of unknown civilizations that adapted to and thrived in diverse environmental conditions throughout history. While there is no concrete evidence that ancient civilizations practiced advanced forms of genetic manipulation as we understand it today, some researchers have speculated about possible early forms of selective breeding and hybridization in ancient cultures. Ancient Mesopotamian and Egyptian texts describe the artificial pollination of date palms, suggesting an understanding of plant reproduction and the ability to influence genetic outcomes. The selective breeding of animals and crops has been practiced for thousands of years, with early farmers choosing the best specimens to propagate desirable traits. In the Americas, ancient peoples developed maize from its wild ancestor teosinte through selective breeding over many generations. This transformation represents a significant, albeit gradual, genetic modification. Similarly, the Inca and their predecessors in South America cultivated thousands of potato varieties, adapting them to different elevations and climates. Some researchers have pointed to ancient artwork and myths as potential evidence of genetic experimentation, such as the Egyptian Sphinx or Greek chimeras. However, these claims remain highly speculative and are not supported by mainstream scientific consensus. The idea of advanced genetic manipulation in ancient times remains largely in the realm of pseudoscience and alternative theories rather than established historical fact. Recent discoveries of ancient crop varieties have sparked a re-evaluation of our understanding of agricultural development. These findings suggest that early humans may have been cultivating plants much earlier than previously thought, potentially pushing back the timeline of agriculture by thousands of years. One example comes from archaeological sites in the Fertile Crescent, where researchers have unearthed evidence of wheat cultivation dating back over 11,000 years. This challenges the conventional belief that organized agriculture began around 10,000 years ago. The wheat varieties found at these sites show signs of intentional selection, indicating that early humans were already actively choosing and propagating plants with desirable traits. In South America, studies of ancient quinoa remains have revealed that this crop was domesticated at least 7,000 years ago, much earlier than initially believed. This discovery not only extends the history of quinoa cultivation, but also suggests a more sophisticated understanding of plant breeding among ancient Andean civilizations. These findings force us to reconsider the pace and complexity of early agricultural development. They imply that our ancestors possessed a deeper knowledge of plant genetics and cultivation techniques than previously credited, prompting a reassessment of the origins and evolution of human civilization itself. Long before the discovery of DNA and the development of modern genetics, ancient civilizations demonstrated a remarkable understanding of heredity and selective breeding. The Babylonians, as far back as 6,000 years ago, kept detailed records of date palm traits and used this knowledge to cultivate superior varieties. They recognized that certain characteristics were passed down through generations and actively selected for desirable traits. In ancient China, farmers developed an intricate system of rice cultivation, selectively breeding strains for different growing conditions and culinary purposes. This practice, refined over thousands of years, resulted in the diverse array of rice varieties we see today. The Chinese also applied similar principles to silk production, carefully selecting moths with desirable traits to produce higher quality silk. Native Americans in Central and South America transformed a wild grass called teosinte into maize through selective breeding over several millennia. This process required an intuitive understanding of genetic inheritance, as they consistently chose plants with larger, more nutritious kernels for subsequent plantings. The result was a staple crop that bore little resemblance to its wild ancestor. In the realm of animal husbandry, the ancient Bedouin tribes of the Arabian Peninsula kept meticulous genealogical records of their prized horses, ensuring the propagation of desired traits such as speed, endurance, and temperament. This practice, maintained for centuries, led to the development of the Arabian horse breed, renowned for its distinctive characteristics. These examples highlight how ancient cultures, through careful observation and selective breeding, laid the groundwork for our modern understanding of genetics. Ancient animal breeds offer intriguing evidence of sophisticated selective breeding practices that predate modern genetic science. The existence of certain dog breeds, for instance, points to deliberate human intervention thousands of years ago. The diverse range of canine body shapes, sizes, and temperaments we see today began with ancient peoples carefully choosing and breeding dogs with desirable traits. In agriculture, ancient grain varieties show signs of artificial selection. Wheat, for example, underwent significant changes that made it more suitable for human cultivation and consumption. The development of non-shattering seed heads, which prevent seeds from dispersing naturally, indicates that early farmers were selecting for traits that made harvesting easier. Livestock breeds also provide evidence of advanced breeding techniques. The existence of wool-bearing sheep suggests that humans actively selected for animals with longer, more useful fleece. This process likely took place over many generations, with shepherds choosing the woolliest animals for breeding. These examples demonstrate that our ancestors had a sophisticated understanding of heredity and breeding long before the advent of modern genetics. They recognized desirable traits and systematically bred animals to enhance these characteristics, laying the groundwork for the diverse array of domesticated species we have today. Genetic studies have revealed fascinating evidence of prehistoric gene flow between populations that were once thought to be completely isolated. By analyzing ancient DNA extracted from fossils and comparing it to modern human genomes, scientists have uncovered a complex web of interactions between our ancestors. One striking example is the discovery of Neanderthal DNA in modern human populations outside of Africa. This genetic legacy suggests that early humans interbred with Neanderthals after migrating out of Africa around 100,000 years ago. Remarkably, people of European and Asian descent today carry between 1% and 4% Neanderthal DNA in their genomes. Similarly, genetic traces of another ancient hominin group, the Denisovans, have been found in modern populations, particularly in Oceania and parts of Southeast Asia. Some indigenous populations in these regions have up to 6% Denisovan ancestry, indicating significant interbreeding events in the distant past. More recent studies have also uncovered evidence of gene flow between ancient Native American populations and groups in Eurasia, challenging previous assumptions about the isolation of the Americas after initial colonization. This genetic exchange suggests multiple waves of migration and interaction across the Bering Strait, painting a picture of dynamic population movements and interactions throughout prehistory. Ancient agricultural techniques reveal a deep understanding of ecological principles that often surpasses modern expectations. The Aztec Chinampa system, developed over 1,000 years ago, exemplifies this sophisticated knowledge. These floating gardens, created in shallow lake beds, utilized layers of vegetation, mud, and decaying organic matter to form incredibly fertile plots. This method not only maximized land use in water-rich areas, but also created a self-sustaining ecosystem where fish thrived in the surrounding canals, providing both fertilizer and an additional food source. In the Andean highlands, ancient farmers developed an ingenious system called waru-waru, or raised field agriculture. By creating a network of elevated fields surrounded by water-filled canals, they effectively modified the microclimate. The water in the canals absorbed heat during the day and released it at night, protecting crops from frost and extending the growing season. This system also improved soil drainage and fertility, demonstrating a nuanced grasp of heat transfer, soil science, and microclimates. The Aboriginal Australians practiced fire stick farming, a land management technique that involved controlled burning of vegetation. This method promoted biodiversity, prevented larger, more destructive wildfires, and created a mosaic of habitats that supported a wide variety of plant and animal species. Their understanding of fire ecology and its role in shaping ecosystems showcases a sophisticated environmental awareness that modern science is only now beginning to fully appreciate. These ancient techniques highlight how our ancestors developed sustainable, productive agricultural systems by closely observing and working with natural processes. Their methods often integrated food production with ecosystem management, revealing an holistic understanding of ecological relationships that many modern agricultural practices have lost sight of. Several ancient foods and medicines hint at a sophisticated understanding of biochemistry that predates modern scientific methods. The fermentation of foods and beverages, practiced for thousands of years across cultures, demonstrates an intuitive grasp of microbial processes. Ancient Egyptians used moldy bread to treat infected wounds, unknowingly harnessing the antibiotic properties of certain fungi millennia before the discovery of penicillin. In traditional Chinese medicine, the herb ephedra was used to treat respiratory ailments containing compounds similar to modern decongestants. Willow bark, rich in salicylic acid, was utilized by many ancient cultures as a pain reliever, foreshadowing the development of aspirin. The Aztecs' use of spirulina algae as a protein-rich food source reveals an understanding of nutritional complexity. These examples suggest that ancient civilizations possessed a deep, if empirical, knowledge of the biochemical properties of various substances. Through observation and experimentation over generations, they developed effective remedies and nutritional practices that align with modern scientific understanding. This ancient wisdom forms the foundation of many contemporary medical treatments and dietary recommendations. While these ancient practices were not based on the scientific method as we know it today, they demonstrate the remarkable ability of our ancestors to identify and utilize beneficial biochemical properties in their environment. This knowledge, accumulated over centuries, paved the way for modern advancements in pharmacology and nutrition. Recent archaeological discoveries of ancient crop remains have significantly altered our understanding of plant domestication timelines. These findings suggest that humans began cultivating certain plants much earlier than previously thought, pushing back the dates of agricultural origins in various regions around the world. One striking example comes from the Fertile Crescent, where researchers uncovered evidence of wild cereal cultivation dating back over 11,000 years. This predates earlier estimates by at least a millennium, indicating that the transition from hunting and gathering to farming began earlier and was likely more gradual than once believed. In the Americas, Ancient squash seeds discovered in Mexico have been dated to around 10,000 years ago, several thousand years earlier than previously known domestication dates for this crop. Similarly, in China, rice grains found at archaeological sites suggest that rice cultivation may have started as early as 9,000 years ago, much earlier than traditional timelines indicated. These discoveries challenge the conventional narrative of a rapid agricultural revolution and instead point to a long period of experimentation and gradual adoption of farming practices. They also highlight the complex relationship between humans and plants, showing that our ancestors were actively shaping their environment and food sources long before the emergence of settled agricultural societies. Ancient civilizations developed sophisticated pest control techniques that were remarkably effective for their time. Archaeological evidence from Egypt reveals the use of predator animals like cats to protect grain stores from rodents as far back as 4,000 years ago. This practice not only safeguarded food supplies, but also led to the domestication of cats. In ancient China, farmers employed biological control methods by introducing natural predators to combat crop-destroying insects. Records from 2,000 years ago describe the use of ants to control citrus pests, showcasing an early understanding of ecosystem balance. The Romans contributed significantly to pest management with their advanced agricultural practices. They developed early forms of crop rotation and intercropping, which helped reduce pest populations naturally. Roman texts also mention the use of plant-based insecticides, such as extracts from hellebore and lupine, to protect crops. Perhaps most intriguing is the discovery of chemical pest control in ancient Mesopotamia. Cuneiform tablets from Sumerian times, dating back 4,500 years, contain recipes for sulfur-based compounds used to eliminate crop-damaging insects. This early form of chemical warfare against pests demonstrates the ingenuity of ancient farmers in protecting their harvests and ensuring food security for their civilizations. Ancient breeding practices and modern genetic engineering share fundamental principles despite the vast technological differences. Both aim to enhance desirable traits in organisms, whether plants or animals, to better serve human needs. Our ancestors, without knowing about genes or DNA, practiced selective breeding. They chose the best crops and animals with preferred characteristics and bred them together. Over generations, this led to offspring with amplified desirable traits. This process mirrors the goals of genetic engineering, but on a much slower timescale. Modern genetic engineering allows scientists to directly manipulate genes, achieving in one generation what might have taken our ancestors centuries. However, the core concept remains the same: altering the genetic makeup of organisms to enhance specific qualities. Both approaches seek to improve traits like disease resistance, yield, and adaptability to different environments. Interestingly, some ancient techniques foreshadowed modern practices. Grafting in plants, for instance, where tissues from one plant are inserted into another, is similar in principle to how scientists now insert specific genes into organisms. This shows that while our tools have advanced dramatically, the underlying aims of genetic modification have remained consistent throughout human history. Several ancient artifacts have puzzled historians and archaeologists, hinting at a possible understanding of electricity long before its official discovery in modern times. One of the most intriguing is the Baghdad Battery, discovered in Iraq and dating back to the Parthian period, around 2,000 years ago. This artifact consists of a clay jar containing a copper cylinder and an iron rod, which some researchers believe could have been used to generate a small electric current when filled with an acidic liquid. In ancient Egypt, elaborate carvings in the Temple of Dendera depict what some interpret as large light bulbs or electrical lamps. These controversial reliefs show elongated bulb-like objects with snake-like filaments inside, supported by what appear to be cable-like structures. While mainstream Egyptologists often dismiss these as symbolic representations, others argue they could indicate an advanced understanding of electrical phenomena. Another curious find comes from pre-Columbian America. Some gold artifacts from the Quimbaya civilization, dating back to around 1,000 years ago, bear a striking resemblance to modern aircraft. These golden objects, often called Quimbaya airplanes, feature delta wings and stabilizers that some researchers claim could only have been designed with an understanding of aerodynamics and possibly electrical propulsion. While these artifacts remain subjects of debate among scholars, they continue to fuel speculation about ancient civilizations potentially possessing advanced technological knowledge. However, it is important to approach such claims with scientific skepticism, as many alternative explanations exist for these intriguing objects. Ancient structures around the world have long fascinated researchers with their seemingly inexplicable energetic properties. The Great Pyramid of Giza, for instance, has been found to concentrate electromagnetic energy in its internal chambers and under its base. Scientists have discovered that when the pyramid is exposed to radio waves of certain frequencies, it can focus this energy, potentially for use in nanoparticle research and other applications. In South America, the ancient city of Tiwanaku showcases remarkable acoustic properties. The semi-subterranean temple within the complex creates unusual sound effects, with voices and sounds appearing to come from all directions simultaneously. This acoustic phenomenon, likely intentional in design, suggests an advanced understanding of sound manipulation by its ancient builders. The megalithic stone circles of the United Kingdom, such as Stonehenge, have been observed to create unusual energy fields. Researchers have detected electromagnetic variations within these circles, with some theorizing that these structures might have been used for healing or other energy-related purposes in ancient times. These unexpected energetic properties in ancient structures continue to puzzle modern scientists, hinting at a sophisticated understanding of natural forces by our ancestors. As we uncover more about these phenomena, we gain new insights into the knowledge and capabilities of ancient civilizations, challenging our perceptions of technological progress through history. Ancient civilizations demonstrated a remarkable understanding of magnetism, far beyond what many might expect. The earliest known reference to magnetism dates back to ancient China, where lodestones were used for divination as early as 2,000 years before the Common Era. These naturally magnetized pieces of magnetite were believed to have mystical properties, but their use in rudimentary compasses shows a practical application of magnetic principles. In ancient Greece, the philosopher Thales of Miletus described the strange properties of lodestones around 600 years before the Common Era. He noted their ability to attract iron, marking one of the earliest recorded observations of magnetic phenomena in Western literature. This understanding was further developed by later Greek and Roman scholars who conducted experiments and documented their findings on magnetic properties. Perhaps the most intriguing evidence comes from Mesoamerica. The Olmec civilization, which flourished over 3,000 years ago, created and used sophisticated compasses made from lodestone. These compasses were used not just for navigation, but also in the precise alignment of their ceremonial structures and urban planning. The fact that these ancient people could create such accurate instruments suggests a deep understanding of Earth's magnetic field and its properties. In India, ancient medical texts from around 1,000 years before the Common Era describe the use of magnets in surgery. These texts suggest that Indian physicians understood the magnetic properties of certain materials and attempted to use them for medical purposes, hinting at an advanced comprehension of magnetism's potential applications beyond navigation. Archaeological evidence from several ancient sites around the world has puzzled researchers due to signs of extreme heat exposure that seem inconsistent with the technological capabilities of their respective eras. One notable example is the vitrified forts found in Scotland, where stone walls appear to have been subjected to temperatures high enough to melt and fuse the rock. These temperatures far exceed what could be achieved with typical wood or coal fires of the time. Similarly, in parts of the Middle East, archaeologists have discovered areas of sand transformed into a glass-like substance, requiring temperatures over 1,600 degrees Celsius. This phenomenon, known as trinitite, is typically associated with nuclear explosions or other extreme heat events not thought possible in ancient times. In South America, particularly at Pumapunku in Bolivia, Some of the precisely cut stone blocks show signs of heat damage that modern engineers find difficult to explain. The level of precision in these cuts, combined with the apparent heat effects, has led to speculation about advanced ancient technologies or external influences. While these findings have sparked numerous theories, ranging from ancient atomic weapons to extraterrestrial involvement, most scientists remain skeptical of such explanations. They continue to search for natural or previously unknown technological processes that could account for these puzzling heat-related anomalies, emphasizing the need for further research and analysis to unravel these ancient mysteries. Throughout history, various ancient texts have mentioned mysterious energy sources that continue to puzzle modern scientists. One intriguing example is the description of the eternal flame in ancient Greek and Roman writings. These texts speak of fires that burned for years without any apparent fuel source, defying our current understanding of combustion. Indian Vedic literature refers to a substance called soma, which supposedly granted superhuman abilities and boundless energy. Despite extensive research, the true nature and composition of soma remain elusive to contemporary scholars. Similarly, ancient Egyptian hieroglyphs depict devices resembling modern batteries known as the Baghdad batteries, whose purpose and function are still debated. The Bible mentions the Ark of the Covenant, described as a powerful artifact capable of emitting energy and light. Some researchers speculate it might have been an advanced technological device, though no concrete evidence supports this theory. In South American legends, particularly those of the Inca, there are accounts of a mysterious substance called vril, purported to be an infinite energy source. These ancient descriptions of inexplicable energy sources continue to captivate researchers and fuel speculation about lost knowledge or advanced technologies in antiquity. While many of these accounts may be exaggerations or misinterpretations, they remind us that our understanding of energy and its potential sources is still evolving. Certain ancient artifacts have sparked intrigue among researchers due to their potential connection with piezoelectric properties. Piezoelectricity is the ability of some materials to generate an electric charge in response to mechanical stress. Some archaeological finds suggest that ancient civilizations might have harnessed this phenomenon, whether intentionally or by chance. One notable example is the use of quartz crystals in various ancient cultures. Quartz is a well-known piezoelectric material, and its presence in ceremonial objects and tools has led some scientists to speculate about its possible applications. For instance, certain pre-Columbian artifacts from Central and South America contain quartz components that, when subjected to pressure, could potentially produce small electrical charges. Another intriguing case involves ancient Egyptian ceramics. Some studies have suggested that the specific composition and structure of certain Egyptian ceramic artifacts might exhibit weak piezoelectric properties. While the effect would be minimal, it has led to discussions about whether this property played any role in the object's creation or use. These findings have prompted researchers to reconsider the technological capabilities of ancient civilizations. However, it is important to note that while these artifacts demonstrate properties consistent with piezoelectricity, conclusive evidence of intentional exploitation of this phenomenon in antiquity remains a subject of ongoing research and debate. Throughout history, various civilizations have demonstrated an intriguing understanding of Earth's natural energy fields, though the evidence is often subject to interpretation. One compelling example is the ancient Chinese practice of feng shui, which involves aligning buildings and objects with what they believe to be Earth's energy flows. While not technology in the modern sense, this practice suggests an awareness of subtle environmental forces. More tangible evidence comes from the precise alignments of ancient structures like Stonehenge in England and the Great Pyramid of Giza in Egypt. These monuments show remarkable astronomical alignments, potentially indicating an advanced understanding of Earth's relationship to celestial bodies and the energy patterns this creates. Some researchers propose that these structures might have been designed to harness or amplify natural energy fields, though this remains a topic of debate among scientists. In South America, the Nazca lines of Peru present another puzzling case. These enormous geoglyphs, only fully visible from the air, have led some to speculate about advanced surveying techniques and a possible understanding of Earth's magnetic fields for their creation. However, mainstream archaeology attributes their construction to more conventional methods. While these examples are intriguing, it is important to note that much of the evidence for ancient energy harnessing technologies remains speculative. Modern scientific understanding of Earth's energy fields, such as geomagnetic forces, has only developed relatively recently, making it challenging to definitively prove the existence of such advanced knowledge in ancient times. The search for conclusive evidence continues, fueling ongoing research and debate in this fascinating area of study. Ancient structures like the Great Pyramid of Giza have sparked theories about advanced technological knowledge in early civilizations. The internal structure of the Great Pyramid, with its network of chambers and shafts, has led some researchers to propose that it might have functioned as a wireless energy transmitter. The pyramid's limestone blocks contain traces of quartz crystal and metals, materials known for their electrical conductive properties. The location of the pyramid is also significant, situated at the center of the Earth's landmass and aligned to true north with remarkable precision. This positioning has fueled speculation about its potential role in harnessing and distributing energy. Some theorists suggest that the pyramid's shape and composition could have allowed it to concentrate electromagnetic energy in its internal chambers and direct it outward. Similar ideas have been proposed for other ancient sites, such as Stonehenge in England. The arrangement of the massive stones has led to hypotheses about their potential to create a circular waveguide for electromagnetic energy. While these theories remain highly speculative and lack mainstream scientific support, they continue to intrigue those seeking alternative explanations for the purpose of these monumental structures. It's important to note that while these ideas are fascinating, they remain unproven. The scientific consensus maintains that these structures served ceremonial, religious, or astronomical purposes rather than technological ones. However, the precision and complexity of these ancient monuments continue to inspire wonder and speculation about the knowledge and capabilities of our ancestors. Ancient civilizations have left behind intriguing evidence of sophisticated mining practices that continue to puzzle modern scientists. In South America, particularly in Peru and Bolivia, researchers have discovered extensive tunnel networks deep within mountains. These tunnels, some dating back thousands of years, show signs of precision cutting and smooth, almost polished surfaces that are difficult to explain with conventional ancient tools. What makes these discoveries even more remarkable is the lack of soot or other residues typically associated with traditional fire-setting techniques used in ancient mining. This absence has led some researchers to speculate about the possibility of advanced energy extraction methods. The clean, precise cuts in solid rock have prompted theories about the use of advanced technologies, possibly involving concentrated solar energy or other unknown power sources. Further adding to the mystery are ancient texts and legends that describe luminous stones and other light-emitting objects used by past civilizations. While these accounts are often dismissed as myths, the combination of these stories with the physical evidence of advanced mining techniques has sparked interest in the potential for lost knowledge of energy manipulation. It is important to note that while these findings are fascinating, they remain the subject of ongoing debate and research in the scientific community. The search for conclusive evidence of advanced energy extraction in ancient times continues, challenging our understanding of human technological development and leaving open the possibility of forgotten knowledge waiting to be rediscovered. Many ancient religious practices, when viewed through a modern scientific lens, show intriguing parallels to our current understanding of energy manipulation. Meditation, a cornerstone of numerous spiritual traditions, has been found to alter brainwave patterns and affect the body's energy consumption. Scientists have observed that experienced meditators can consciously control their metabolic rates, effectively managing their internal energy. The concept of life force or vital energy, known as qi in Chinese traditions or prana in Indian philosophy, bears some resemblance to our modern understanding of bioelectricity. These ancient ideas posited an invisible force flowing through living beings, not unlike the electrical impulses we now know course through our nervous systems. Some traditional healing practices, such as acupuncture, have been studied for their effects on the body's electromagnetic fields. While the underlying mechanisms are still debated, research has shown that acupuncture can influence electrical activity in the body and potentially alter pain perception. Certain ritualistic practices involving rhythmic movement or chanting can induce altered states of consciousness. From a scientific perspective, these states correlate with specific brain activity patterns and changes in the body's energy utilization. This alignment between ancient practices and modern energy concepts highlights the intuitive understanding our ancestors had of the human body and its interaction with the environment.